Are you ready to take your game development skills to the next level? My name is Alex and I'm presenting the ultimate guide to creating your own RPG game. With this course you'll learn how to create a fully functional RPG from scratch, even if you have no previous experience. I understand that creating an RPG game can be challenging, so I will teach you everything step by step. This course is designed to be beginner-friendly, yet comprehensive enough to challenge experienced developers. You'll learn how to create a finite state machine that you can expand as much as you want, with different skills, movements, and basically anything that comes to your mind. I'll show you how to make levels, parallax effect, camera controller, and that is just the beginning. After that we'll introduce an enemy to the game, so you have someone to fight against. As a part of this process you'll master the concept of the state machine, giving you the ability to create various types of enemies to make your game even more exciting. You'll create an engaging combat system with mechanics that any modern game has, such as dashes, counterattack, and skills. Oh, and skills. We're going to develop not just a few, but an entire skill tree. Skill tree that you can upgrade to improve your skills in different ways. And it won't be just an upgrade, it may change the behavior of the skills entirely. And that is just the tip of the iceberg. Because after that, we'll jump to systems that will turn this game into a fully functional RPG. Items that can affect your stats, craft system with materials and recipes of unique items which can buff player, debuff enemy or trigger some special attacks. In addition, we'll make a stat system with critical attacks, evasion, magical damage, different elements that will affect enemy and yourself in different ways. We're going to create UI to manage all of that, and I will teach you how to make a save system that allows you to save any of your progress, such as checkpoints, items, skills, experience, currency, you name it. Of course, there is a scene management, audio manager, souls pickup, just like in Dark Souls, and we are going to finalize it with the polish stage, in which we are going to improve game mechanics, visual effects, particles, and then finally build and publish. By the end of this course, you'll have all of the tools you need to create your own unique RPG game that you can share with your friends, family, or maybe publish as a full-time indie game developer. Ready to turn your game ideas into reality? Let's make it happen. Enroll in my course today and start creating your dream RPG game. Hello guys, and first of all I want to say thank you for enrolling into my course. Your support means a lot to me. Not only you will be learning something new, but also your support helps me to continue creating more courses in different game genres and get more people involved into game development industry. I'm excited to work with you and share my knowledge and experience. But before we begin, I want to share with you the mindset I had when I was creating this course and some important things you should know before you start. I built this course in a way real development works, so you will not see a flawless steps on how to make a game from scratch to finish with 0 bugs in it, because that is not how development works. This course built with a goal of showing real life experience on making a game. We'll define a problem, we'll think what we can do to make it work, and we'll do it. And if we face a bug or misbehavior, we'll fix it together. I'll explain why it's happening and what we need to do to make it work better. So once you're done with this course and you decide to make your own video game, you will be ready and you will know what could go wrong and what you can do to fix it. It's a very high chance this is your first attempt to make a video game, and I keep that in mind. I haven't missed a single step of development. I understand that probably this is your first or second game. I will show you every step and you will know everything you need to know to make it work. If this is your first time coding or just in Unity, please don't get discouraged. It is 100% normal that you won't understand everything at the beginning. Just don't think this is not for you or this is too complicated. Nothing is complicated and you are smart enough. You just need a bit of practice. I remember myself when I just started in Unity and it felt like a control panel of a spaceship. You just need to keep going and practicing, and eventually Unity and C# will become a comfortable tool that you use to make your own video games. Just remember, everyone has different learning speed and it really doesn't matter what is yours. At some point you will get there, just keep practicing as much as you can. Follow me in my steps. You always and always need to do what I do. It is fundamental. You will learn nothing if you don't practice. Even if you don't understand and you are just typing what I'm typing, you need to do it. As long as you are coding, it's getting into your brain and you are learning. Your brain trying to understand all of it as a background process. Just to give you an example of what I mean, I'll picture a situation for you. You ever had a time when you couldn't remember someone's name and you try and you just cannot remember? Finally you give up and you start doing some other things, and then suddenly it pops in your head. Oh, his name was Alex. It happens because your brain working on a task unconsciously. It is very same here. Your brain trying to figure out what is happening. Plus you're training your kind of muscle memory. If you practice a lot, your hands will know what to do before you even think about it. So as I said, practice and do everything together with me. Last thing I want to say in this video is that there are many different students and this course is for everyone. Some never used Unity or never coded anything in their life. Some have experience of another programming language. And some built their games before, but they want to learn new systems that are covered in this course. And this course for all of you. Everyone is welcome. So I want to ask you, do not write a bad review if you feel like this course is too easy or too hard, too slow or progressing too fast. I built this course with everyone in mind. To make this course perfect for you, you can always change speed of the video, use rewind or fast forward button. You can watch video again if you didn't catch something, or you can increase speed of the video if you feel like this is easy for you. Of course, you can give any review you like, but please make sure that they are deserved by this course. I put a lot of work in it, and I really hope you will like it. That's all what I wanted to share in this video, but make sure you watch all of the videos in this section. Thank you for paying attention, and I'll see you in the next video. Hello guys, in this video I want to talk about difficulty of the course. Please hear me out, this information is important. Alright, so first of all, it is important to remember that creating a video game, especially an RPG, is not an easy task. It's a complex, challenging process that requires time, effort, and willingness to learn. But don't worry, I'm here to guide you through the process and explain everything in details. I want to be sure it's clear, so I'll repeat once again. Making an RPG game can be challenging even for experienced developers. And this course covers complex systems. However, with detailed explanation and guidance, you will be able to overcome any difficulty. Very important, hear me out. If you have zero experience, I suggest you complete one of my courses for complete beginners, such as Platformer, 2D Platformer, or Endless Runner. However, if you don't want or you can't do that, I prepared a crash course section that is 3 hours and 15 minutes long. You could call it a zero section. If you have experience, completing this section will help refresh your memory and see the difference between the regular approach and the state machine approach we're going to do. Just in case if I scared you just now, I wanna say, don't worry man, it's okay. I made a very similar game to the one we're about to make when I had just 1 or 2 months of experience, I don't remember. Basically, I just had the knowledge that you'll learn in a crash course. So if I could do it, I'm confident that you can do it too. Very important, again, right after crash course, I'm going to act like nothing happened. I'm going to delete everything and start over. Because crash course, hear me out, this is important, is not a part of main course. It's only there for those brave souls who decided to make RPG game as their first game. Now, let me tell you in what cases you can easily skip the crash course. If you can answer all of these questions I'm about to ask, or at least some of them, you are good to start the main part of the course, which is the player's finite state machine section. If you cannot answer them, I suggest completing one of my other courses, such as Runner or Platformer, or at least beat the crash course section. Alright? Here are the questions. What is a collider? What is a rigid body? How to make rigid body move to the right? How to make character move with keyboard input? How to make character jump? What will happen to the character if you reduce his velocity on the Y? What will happen to the character if you reduce his velocity on the X? What is a serialize field? How to cut a sprite sheet? What is an animator? How to make animation? How to make a blend tree in the animator? How to make ground detection with collision detection? How to use timers and time.delta time? One of the most important, what is inheritance? And what is the difference between protected and private? And one of the last questions, what is the difference between public virtual void and public void? Alright, so if you could answer these questions pretty much like easily or at least at some level, I guess you're good to skip crash course section, but still would be nice if you would do it. Alright, so thank you for paying attention in this video. This is important to know, and just watch the next one. See you. Hello guys, in this video I want to talk about difficulty of the course. Please hear me out, this information is important. Alright, so first of all, it is important to remember that creating a video game, especially an RPG, is not an easy task. It's a complex, challenging process that requires time, effort, and willingness to learn. But don't worry, I'm here to guide you through the process and explain everything in details. I want to be sure it's clear, so I'll repeat once again. Making an RPG game can be challenging even for experienced developers. And this course covers complex systems. However, with detailed explanation and guidance, you will be able to overcome any difficulty. Very important, hear me out. If you have zero experience, I suggest you complete one of my courses for complete beginners, such as Platformer, 2D Platformer, or Endless Runner. However, if you don't want or you can't do that, I prepared a crash course section that is 3 hours and 15 minutes long. You could call it a zero section. If you have experience, completing this section will help refresh your memory and see the difference between the regular approach and the state machine approach we're going to do. Just in case if I scared you just now, I wanna say, don't worry man, it's okay. I made a very similar game to the one we're about to make when I had just 1 or 2 months of experience, I don't remember. Basically, I just had the knowledge that you'll learn in a crash course. So if I could do it, I'm confident that you can do it too. Very important, again, right after crash course, I'm going to act like nothing happened. I'm going to delete everything and start over. Because crash course, hear me out, this is important, is not a part of main course. It's only there for those brave souls who decided to make RPG game as their first game. Now, let me tell you in what cases you can easily skip the crash course. If you can answer all of these questions I'm about to ask, or at least some of them, you are good to start the main part of the course, which is the player's finite state machine section. If you cannot answer them, I suggest completing one of my other courses, such as Runner or Platformer, or at least beat the crash course section. Alright? Here are the questions. What is a collider? What is a rigid body? How to make rigid body move to the right? How to make character move with keyboard input? How to make character jump? What will happen to the character if you reduce his velocity on the Y? What will happen to the character if you reduce his velocity on the X? What is a serialize field? How to cut a sprite sheet? What is an animator? How to make animation? How to make a blend tree in the animator? How to make ground detection with collision detection? How to use timers and time.delta time? One of the most important, what is inheritance, and what is the difference between protected and private. And one of the last questions, what is the difference between public virtual void and public void? Alright, so if you could answer these questions pretty much like easily or at least at some level, I guess you're good to skip crash course section, but still would be nice if you would do it. Alright, so thank you for paying attention in this video, this is important to know, and just watch the next one. See you. Hey there, and welcome to the last video in the Watch Before You Start section. Just wanted to take a moment and give you a bit of a pep talk before we dive into technical details. First of all, just once again, I want to say that I'm really glad you decided to join the course. It means a lot to me that you've chosen to learn from me, and I'll do my best to make sure you got the most out of it. That being said, I want to remind you that game development is not easy, there will be challenges along the way, and sometimes things won't work out as planned, but that's okay. Don't stress out because of that, it's all part of the process and it is how we learn and grow. If you want to stay up to date on my latest projects and tutorials, be sure to follow me on social media. You'll find links to all my profiles on my instructor page, so be sure to check that out. And don't forget to check out my other courses as well. I cover a wide range of game development topics, so there is something for everyone. But above all, the most important things I want to say is just have fun. Game development is a creative and rewarding field, and it is important to enjoy the journey as much as the destination. So take a deep breath, get excited, and let's get started. Thanks again for joining, and I'll see you in the next video.
Hello guys, in this video we're gonna set up Unity, we're gonna install Visual Studio, and we're gonna install Unity Hub. I assume some of you already have Unity on your computer and you know how to install it, you don't need to see those steps. But just to be on the safe side for those who are doing it for the first time, I want to show process of installation and basically making a game from state of the empty computer up to posting your game on the website. This is what we're going to do. And in this video, we're going to focus on installing Unity Hub, Visual Studio. If you want, if you have those stuff already installed, you can just increase speed of the video to see the main steps and just maybe update your Visual Studio up to mine if it's not. And yeah, basically that's it. Let's begin. So what I'm gonna do is open unity.com and then I'm gonna click get started. The only step I'm gonna skip is creation of the account. You can do it on your own. I will not do that. So you click get started and then you need to find where is it? The free version, Unity Personal. You don't have to pay for Unity. You don't have to pay for your earnings from Unity unless you're making more than 100K per year. So yeah, we're gonna do free. We're gonna do download for Windows. And I'm just gonna click open here. So I don't have to save that file, only use it once for installation. I agree. I'm gonna use my own way. You can use your own way for installation. I have a bunch of folders and it's kind of a mess on my computer, but that's okay. Game dev. Unity. No, just game dev. Okay. Install. Okay, I'm gonna run Unity Hub. I'm gonna pin it to the taskbar because I'm gonna use it a lot. So I need it here. I'll move it here. Now you need a space where you're gonna install your editors. And I have my own folder. Unity. You can create a folder wherever you want, what is more comfortable for you. We're gonna click install Unity Editor and it's gonna chose the latest one, but just for this video, for the purpose of this video, I'm gonna skip installation and I'm gonna do it from the Unity Hub itself. Here you're gonna have your projects, like I have a bunch of projects here now. We're gonna go to install editor, and now we can choose the version we want. I suggest you choose the latest LTS, long-term support, because this one less likely gonna have bugs comparing to the other version, which is latest, but not as tested as long-term support. You click install. Don't worry if you don't select some of these, because you can always return and install them later. And I'm gonna uncheck Visual Studio because I want to install Visual Studio over 22. All right, so I'm just gonna click install of the editor without checking these checkboxes here. Install. It may take some time, so I'll speed up the video and I'll come back to you once it's ready. Now we can see install is complete, and next step would be to install Visual Studio, so don't rush into creating project yet. We need to go to Google and just type Visual Studio 2022. It's just my personal preference to install 22. You can use 19 and it's gonna be completely fine, absolutely. It's just my personal preference. So I'm gonna choose Community 22. Tell you more after installation. I'm gonna use theme from 2019, so it looks same as yours completely. Continue. Okay, here we're gonna choose, where is it? Unity game development with Unity. And if you use a 19, again, it's going to be same. So don't worry, just choose game development with Unity, install while downloading, and we need to wait again. As you can see, it automatically took my account. Probably you would have to create your own if you don't have it yet, but it's supposed to be very easy to do. Now here I'm gonna click continue without code, only for one reason. I wanna go to extension, no wait. Yeah, I wanna go to tools, theme. I wanna click get more themes here. It will send me to a website. And here I want to find dark theme 2019. This is more convenient, I guess. We used to this one. We used this for years, and now I want to have same theme even though I'm using the latest version. Now I'm going to click open. It's going to install itself. Yes, install. Here it will ask me to close the applications, and I'm going to do that, and tasks. Okay, close. Now let me check. We're done with this one. Now we can go back to Unity Hub, and we need to create a project. This will be very easy to do. You just go to projects over here and click new project. Here you can choose editor version if you have a couple of versions installed, but usually late is chosen automatically. So I'm gonna do that. I'm gonna find 2D core because we don't need much, and I'm gonna name it as RPG Udemy course. Yeah, I'm gonna create a project. It may take some time to compile. We're gonna wait for that, and then I'm gonna show you what next we're gonna do. Now we can see Unity is open. I wanna make it maximized on the full screen. And yeah, this is Unity. If you've never seen it before, don't get scared. It's fine, it's cool. I'm gonna teach you how to use it. It's gonna be super easy. The last thing we want to do here before I end this video, just in case we want to attach Visual Studio to the Unity, because sometimes it is not attached and people getting confused. So what we need to do is to go to Edit, Preferences, and in the external tools over here, we need to find Script Editor and choose whatever we want to use. In my case, I'm choosing Visual Studio 22, and just in case, I'm going to click Regenerate Project Files. This is supposed to fix any issue we might have in the future. All right, we're done with this video. Let's go to the next one. And in the next video, we're gonna set up Unity to our needs. And I'm gonna talk a little bit about these windows, what they do. And then we're gonna continue. Let's move on. Hello guys, we are in Unity. And before we begin to make anything, I wanna just discuss a little bit tools and windows in Unity that we have, and it's not so important for you to remember them now. I just want to make you feel a bit more comfortable in the environment and make you to understand and have idea what's this for and what's that for. But in general, if you won't remember anything from this video, it's okay, because later we're gonna use all of the windows and buttons so many times. Eventually, you'll just know what it does. You will understand it and you will use it as your own hands. It will be just a comfortable tool for you. All right, so what we need to do first is go to Window, over here, choose Layouts and choose 2x3. This, in my opinion, most comfortable way to work with 2D projects. We need to take this project window and drag it over here, put it here below. And to make it easier for me to explain, I'm gonna create a square. For that, I'm gonna click right button, find 2D, Sprite, Square, and I'll just keep it with the name square. So what we have here, first of all, we have a hierarchy window. Hierarchy window allows us to see all objects that are in the scene at the moment. For example, you can see I have a square here. If I click it twice, I'm gonna focus on the square. If I zoom out, this is the exact square that we chose, and we can see it in the scene window. This is the scene window. And we can see it in the game window. This is the game window. The difference between them is scene window allows you to see different properties of the object. It allows you to control it. For example, if you choose move tool over here, you can move the object around the scene, but you cannot do it in the game window, because game window is like a final cut, like a rendered object. This is what player will see when he press the play button. All right, and you as a developer, can do controls from here if you need to change something. Cool. Now let's discuss the tools we have in the scene window, and then we're gonna jump to other windows we have in the Unity. I'm gonna click right button and choose horizontal, and I'm gonna resize window just a bit so we have more space. So first, what you need to know, there is a hand tool, or view tool as it's called here, and it's basically same as a hand tool in Photoshop if you ever use that. It allows you to navigate around the scene with your hand and drag around, drag the view around, yeah. But you don't have to select this tool if you want to navigate around. You can have another tool selected, for example, move tool, which allows you to move objects around. And if you want to navigate around the scene, you can just hold the wheel button on your mouse, the wheel button, the middle key, yeah. You can hold it and navigate around just like this, which makes your work much, much faster. You can move around, drag, and you don't need to select a tool. The second thing I want to say here, that you have a hotkeys for these tools, and it's extremely easy to remember them because they are placed from left to right as a Q, W, E, R, T, Y on your keyboard. So if I press Q, you can see selected hand, W, E, R, T. Now let's discuss these tools a little bit. You already know a hand tool, you can move around. You already know a move tool that allows you to move object around. There is an E, rotation tool, which allows you to rotate the object. We're gonna use it sometimes. I'm gonna press Ctrl Z to undo. There is a transform tool, which allows you to resize the object as you need, right? What you need to know as well, it changes scale of the object. And with the square, it's not so noticeable, but if you use a character, for example, it's gonna be really stretched and it looks weird, but I'll show you that later, right? So that's what you can do with the transform tool with the hotkey T on your keyboard. So for example, if you need to create a couple of platforms real quick, you can place one platform, then you can duplicate it with a Ctrl D and then move it here and replace, and you basically have somewhat a level here. Yeah, cool. So this is the tools, and from now on I'm gonna use hotkeys most of the times to save me time and to make my work faster in the long run. If you ever getting confused how I do it so quickly, move it around like that, just you need to know that I'm using these tools and they're easy controlled with the hotkeys from Q, W, E, R, T, Y. Yeah. And the last one here allows you to have all of the tools together, rotate, position, scale, but I've never seen anybody using it actually. Maybe there are some people, I never do. Okay, so I'm gonna take the square, and now I wanna change aspect of the game window over here. I wanna make it 16:9. That is the most common resolution. So it looks a bit more common, I would say, than what I used to see. Cool. Now we have a next window that we need to discuss, and that is the inspector over here. See properties of the object. It's the same if you would click right button on the object in window and click to see properties. Something like, let me show you real quick. So if you go and click properties, this would be your like kind of an inspector in Windows, right? And this is what we have in Unity. This is the inspector that allows you to control, change values, see what it has, and basically we're gonna use it for all of the changes on the game objects. That's how you do it. At the moment, it has two main components. One of them is transform, which allows object to be in the space, to have its position, rotation, and a scale. We can do reset over here to place it in the middle. And it has scale 1. If you want to change position, you can do it and move it to the left or right, just like this. Yeah. And we have a sprite renderer component, which allows you to change look of the object. At the moment it has a square, we can replace it with another picture. This one, for example. I'm gonna undo that. It allows you to control the color and some other properties that we're gonna use later in the course. If you see it for the first time, again, chill out, it's okay, we're gonna learn everything, I'm gonna help you, I'm gonna walk you through it. So again, this is the inspector, it has different components, we can add different components, and we're gonna do that later, and we're gonna discuss them, how they affect the object and how they will be helpful to us. Yeah. And the last window we did not discuss yet is the project. Project allows you to navigate around the files you have in your project, basically, that you can drag to the scene, you can drag to the game, you can change something there, you can add new files. And as an example, we're gonna add a graphics that we're gonna use for our character. As you might know, this section here only to teach you basics of Unity, but still I wanna do it with the same sprite sheet. I wanna show you how to cut sprites, how to prepare them for animation, and how to do animation. I have attached a sprite sheet to this lecture. You can download it, and then what you need to do is to drag it to this window. Let me find it on my, yeah. You just drag it like this. So you have it here. And as an example of what else we can have in a project folder, let's create a script. Create C# script, and I'm gonna name it as player. Well, that's it for this video. All what I wanted you to know about the windows. I'm gonna do a quick review, real quick. Yeah, inspector allows you to control the object, change its properties, and add different components. Hierarchy allows you to see what you have in the scene at the moment. For example, we have a square right now. Scene window allows you to do control of the objects on the scene. Game window allows you to see what you will have in the game later. Project allows you to see what you have in your project. Yeah, cool. Let's go to next video. Hello guys, in this video we're going to discuss 2D physics in Unity. We're not going to do any coding yet, I'm just going to explain stuff, you watch me. I will begin my explanation with a square. I'm going to take it, just move it below a little bit and change size. I'm going to make it like this to make it look like kind of a platform. And I'm going to change color for it. I want to make it darker. Yeah. Cool. Now I'm gonna create another object, 2D object, sprite circle, and I wanna name this as player. I wanna change color as well, so it's more noticeable. Cool. So now we have a square. I'm gonna name it as platform. This is better. So we have a platform and a player, and we want to make them act. If you go to play mode right now, and you can do that by clicking play button over here, you can see nothing is happening because we did not do any changes. We gave a position to the object, we gave it a scale, we gave it a sprite renderer so it has a look, but we did not do anything else. But what if we want to make this ball fall, like a real ball? We can do that. We can do that by adding a component of rigid body. So it will act like a rigid body. Let's do this. Let's find rigid body 2D. And at the moment, if I go to play mode, you can see it's gonna fall. The only problem, it fell through the platform we have. That is happening because look of the object does not define a shape of the object in Unity. If you want to have it some shape, you actually need to add a collider to it. And I will add a collider. I'm gonna cover this, and I'm gonna add a circle collider, and it should be 2D. Okay. So now we can see there is a collider. It's not noticeable because it took a shape of a sprite. But if you click Edit Collider over here, you can change the size. And again, to show you what I mean by saying shape of collider is not defined by the look of it, I'm going to increase the size of the collider like this. And even now, with the collider, the ball gonna fall through the platform, because we did not add a collider to the platform as well, because we don't have collider on the platform, and platform should have collider as well. So two objects can collide between each other. So let's go ahead and do that. We're gonna select platform, we're gonna add component, and we're gonna type box collider 2D. Now it has a collider. We can change size if we want to. Sorry. We can change size if we want to, but we're not gonna do that. So let's go and click play, and we can see it fell, but not entirely, because the shape, again, looks like this. So let's go ahead and fix it and make it default shape as we need. I can do that by clicking reset. Now if I go to play mode, it's gonna fall. Very cool. We can affect gravity of the object if we want to. For example, we can increase the value over here and we're gonna make it from 1 to 5 and it's gonna fall faster. Yeah, almost not noticeable, right? There are different properties we can control on the rigid body, on the collider, and on different components. But if I drop all of the information on you right now, I guess there is no sense in it, because for me personally, it was much easier to learn everything step by step while I'm using it. To understand things on practice is much easier. That's why I'm not gonna tell you each property on the rigid body, what is a body type, what is material, mass, linear, drag, until we need it. So just relax and do steps with me, and eventually you will understand everything you need to know to make an RPG game. Okay? Cool. So, just as an experiment, I'm gonna create 2D physics material over here. I'm gonna name it as material. I'm gonna remove friction and I'll add bounciness 1. And now let's take our player and drag material here to rigid body. Now look what's going to happen. Ball is going to jump. Very cool. You can see the ball every time. You can see that ball every time jumping higher and higher, because it doesn't have any resistance. We need to add some resistance, like air resistance to it, and it will act more naturally. For that, we can increase linear drag. So linear drag allows you to basically, as I said, make an air resistance. Let's do that and increase value to 1.5. Now you can see ball behaves differently. Maybe that's too much. I'm gonna add 0.5 and I wanna pick it up and drop. Boom. Now it acts more naturally. I can increase gravity. It's gonna jump like that. A ball. I cannot catch it. Okay. Boom. Very good. So we have a ball. And if we would want to, we could make some kind of a tennis game with this platform. Just, oh no, fell through. Yeah, anyway, now you know a bit about collision and rigid bodies. I'm gonna delete this material. We don't need this anymore. I just want to show you some more examples that physics in Unity is actually good, especially for 2D. So if you place platform like this, you're gonna see that ball gonna bounce to the right side, how it's supposed to be. If you remove material from it, the bouncy material, then ball gonna drop and roll over. Very cool. And you could make some, I don't know, some game where you need to place the platforms in a way that makes ball reach the final point and not fall. By the way, I'm doing duplication with the Control D. Yay. Boom. And go back. Yeah, so it's kind of fun to play around and see what you can do with different properties. You can increase the gravity scale or make it bouncy again, but maybe less bouncy, maybe just 0.4, and see behavior of the game. Boom, boom. Yeah. All right, that's it for this video. I'm gonna delete a mess I made here. I'm gonna delete material. We're not gonna use it yet. I'm gonna delete extra platforms and I'm gonna reset position of this platform. 0, rotation on the Z, 0, and I'm gonna take my ball and place it 0 on the X and a bit higher and platform lower. Yeah, so I guess that's it for this video. Now you know that shape is defined by the collider, and if you want objects to collide between them, you need to actually add component, right? That's what you need to know. Let's go to the next video. Hello guys, in this video I want to discuss input in Unity because we're going to use it later for different purposes. First of all, what you need to know is there are two ways of doing input. There is old input system and there is a new input system. They have some differences, they can be used in different ways for different purpose, but we're going to use old system. And I don't want the word old scare you, because if it's old it doesn't mean it's bad, it just was made earlier, so it has some differences. But for this project exactly, old input system is much more suitable, that's why we're gonna use it. And if you never did use input before in Unity, it's better to start your journey in Unity with old input. So we have a player script, and to make it work we need to put it on some object. I want to put it on the player, let's do it. And now we can open it by clicking it twice. So this is the Visual Studio we installed before. If you don't see things colored like I do, if all of your code is white, it means it's not associated with Unity. And to fix that, you can go again to Edit, Project Settings. You find, give me a second. Oh no, we need to go Preferences. Here in the external tools, you need to choose your editor and click Regenerate Project Files. Supposed to be fine. Now let's go back. What I want to do here is to discuss execution order. So at the moment we can see void start and void update. And there is a comment that says start is called before the first frame update. And update is called once per frame. That is kind of an important knowledge that everybody should know. So if your game runs 120 frames per second, update gonna be called 120 times per second. And start gonna be called only once before the first frame update. To show you an example what I mean by that, I'm gonna do a short debug. Debug is how you debug any information that you need from code to console. Let's do this. Debug log. I'm gonna write a message and it should be in the quotation marks. Start was called. And then I'm gonna go to update. I'm gonna do debug log. Update is called. Ahoy. Okay, I'm gonna save it with Ctrl S, and then I'm gonna go to Unity. Let's let it compile, it's okay. We don't have a console yet, so we need to go to Window, General, find Console, and we can drag it over here. Now when you go to play mode, you can see that message was called, start was called once, and update is called ahoy, called every time, and it has multiple calls. You can see numbers here. If your console displays messages like this, what you need to do is to click collapse over here, and it's gonna shrink it to 2 messages. So this is what we have. This is how update is called. I need you to know it for different reasons, and the most important is for input, because we're gonna do input now. We're gonna discuss input, and because update is called multiple times per frame, this allows us to check if there was any input all the time. All right, you cannot check input at the start because function called only once, and you basically won't have enough time to do any input you need. But if you need to make some actions at the beginning of the game, like just give a force to your ball so it flies up, you can do it in the start. But if you need to do some input, or if you need to do some movement of the object or play an animation, you always have to do it in the update. Again, because update function called all the time. All right? Cool. Now that we know that, let's do a bit of a coding. I'm gonna go to update and just type, you can repeat after me, just do what I do. If input dot get key down, key code space, then debug.log jump. You always need to have a habit to save your stuff, just like I do, because otherwise it won't work. Until you save the project, Unity won't run your code. Okay. So in the update, we check if there was any input. This is basically, I think you've seen if statement before. Even if you don't have any experience in coding, you know what is if statement, right? It has very simple rule. If something happened, then do this. If some condition is met, then do what I say. So it's basically like, if this, then that. That's it. If light is green, you can go. If light is red, you need to stop. That's how it works. So now we're doing check for key code down space, and we can go and check that in Unity. I'm gonna resize window a bit because we don't have much of the code. Okay, so nothing is happening. And if I press my space key, jump. And then again, jump, jump. Later, instead of a word jump, we're actually going to make object jump. But for now, let's just keep continue and discuss input just a little bit more. So as you can see, I typed here get key down. There are different ways to do input. We have get key down. We have if input. Give me a second. Input get key, and you can see three options here. There is a get key, which means if user holds down the key. Then there is a key down. It means the key reached its lowest level, like it was pressed, and get key up means key was released. So as example, I'm gonna do key code space, and I'm gonna debug message space. You holding space button. Here in the message, I'm gonna type you pressed space button. And another one, if input dot get key down or get key up, key code. Sorry, space debug log. You released space button. Okay, save it. Let's go. So I'll hold the key now. You can see it was pressed once, and then you hold in the space button. If I release it, you release the space button, or you can click it, or you can hold it. And that can be used for different purposes. If you don't want to use a space button, but you want to use something else, just instead of space here, you need to type key code and you choose a key. If you want to see a list of all of the keys, but not here, somewhere else, you can go to browser and just type key code Unity. Okay, and you can see all of the keys here. There is another way to get an input. You can type not get key, but get button. But for this, you need to use names. How do you find names? I'll tell you. Just in the parentheses, you need to type quotation marks and use a name of a button. For example, jump. I know there is a button like this, and that's why I'm typing jump. Jump. Okay, so now we go to play mode. And when I press the jump button, it jumps. How do I know what is a jump button? For that, you can go to Edit, Project Settings. You can find Input Manager, open this Access, and you can find all of the buttons, and you can create your own if you need to. So here's the jump that says name jump, positive button, space, and you can add a negative button, and you can do it even for gamepad if you want. For example, let's say Fire 1 has a positive button, joystick button 0. Which one of the keys on the gamepad? I'm not sure which one. Yeah, so that's how you do input. There is something else you need to know about input, and that is extremely useful for us, and especially for the next video. You can do input of the horizontal or vertical axis. Actually, let me show you them here. again, project settings, input, you can see vertical and horizontal. Horizontal, it's an AD keys or left and right, vertical up and down, or S and W, as in any game that you played before. And we're gonna use that to move the character. But before we do that, let me show you what they debug if you type them in. I can actually just type debug.log input get axis horizontal. So I can debug information like this as well. Let's go back to Unity. So you can see I'm debugging 0 at the moment because I do not touch anything. If I press right arrow or D, we can see I'm getting value getting bigger from 0 to 1, and now it's only 1. And I can make it negative as well if I press to the left. And if you don't want to have a float value that is represented like 0 point something with decimals, you can do get axis row. This is used for more snappy controls. If you want your controls be responsible and immediate, you use get axis row. And now at the moment, -0, it is 1, or -1. 1, you can see debug here, or 0. Okay, and this is what we're going to use later to move the character. At the moment, I want to do only one thing. I want to make a public value here, public float. We're going to discuss what is float and what is public later. For now, just type after me, x input, and in the update, I want to type x input equals to, and I can cut out this line of code and paste it in here, and then save it. Now we can see our input over here on the right side. And if I press any key of the input, we can see value getting changed, 1 or -1 over here. Yeah. Cool. Now let's go to the next video. Let's move this ball around. Hello guys. So now you know a little bit about input. Let's actually use it. All right. So what we're going to do here is I'm going to make this window small because I need to see inspector if I want to explain you the things I want to explain to you. All right, so first, what I want to tell you is the difference between public and private. There are some, but I'm going to tell you about most obvious at first. If you make value public, you can see it in the inspector. If you make value private and save it, you cannot see it in the inspector. And for now, let's keep only that in mind. All right, the rest of the things we're going to discuss later. One of the other differences is that if you make value private, you cannot get access to this value from another script. For example, if player would have an HP, it should be public. Otherwise, we cannot reduce HP from another source, from the enemy, for example. But some of the values should not be public because there is no reason to keep them open and exposed. There is no reason for them to be changed by something else other than player or input of the player, like X input, for example. So we have X input private, and we need somehow to make player move according to our X input. For that, we can change velocity of the rigid body. And again, for the sake of easier explanation, I'm going to make it public, all right? I'm going to do public rigid body 2D, and I'm going to name it as RB. So what I did just now I created a value of a type rigid body, and this rigid body has a name RB. Basically, I created container that can store only one sort of information. Like, you cannot place a horse in a jar of a candies, right? You can place only candies in a jar of a candies because horse is too big, or it just does not have shape that is needed for this jar. That's what we're doing here. When we're creating some data types, we see it as a jar that can store only certain information. And this one can store information about rigid body 2D only. Float can store information about numbers with decimals, like 2.5, 5.6, or whatever number with decimals you can imagine. And now we fill in this float with the input we have. X input equals to input of the axis. But rigid body is empty because we just created, but we did not assign anything here. And if you go to inspector over here, you can see it says none. It is empty. So somehow we need to fill it. And we can do it easily with the rigid body 2D. We can just drag the rigid body here. So now this RB is equals to rigid body of the player. And this RB is the same RB over here. So basically now this RB is equals to this rigid body. And now we have control of this rigid body in our code. Make sense? I hope so. Now, as an experiment, let's go to start function and type rb.velocity equals to new vector2. I'm gonna tell you why vector2 a bit later. For now, let's just type. And we're gonna type 5. And for the y, we're going to do rb.velocity.y. When you type the variable of the rb itself, it means it will use its own velocity. It will not change anything. And that's what we basically need for y, because we just want to push our ball to the right side. So now if I go, I need to save it. I want to place it here. I want to make some platforms, so it won't go off the platform. So now look, when I go to play mode, my ball was pushed to the right side. Why is that? Obviously, of course, because we have our rigid body and we're getting access to its velocity, and then we're setting it to new vector2. But why vector2? Why number 5 pushed ball to the right, not to the upside, not to the left, to the right? Because everything in 2D works on a vector of 2D dimension. So we have y and we have x. If you want to move your object to the right side, you increase its velocity or position on the x. So 5 somewhere here, and we're setting velocity to the right side. If we want to move it to the left, we're gonna do -5. If we want to move it up, then we need to change not the x, but we need to change the y. And we would just make, well, let's make a jump actually. Let's try. We're gonna keep RB velocity 0, and if it's a 0, it will use 0. It will be on one place on the x. But for the y, let's try and make 10. Okay, I'm gonna save it and go back. And you can see my ball flew up, but only once because we used a start function. All right, now I'm gonna delete this code from here for now. I'm gonna go to update and I'm gonna type rb.velocity equals to new vector2. And for the x, I'm gonna use x input. For the y, I'm gonna use rbvelocity.y. So y will not be changed, as you know now, and x input, as we tested before, can have -1 or 1, because we're using getAxisRow. Okay, let's go to play mode. And now if I press my keys, my ball moves to the right. If I stop, it stops. If I press to the left, it goes to the left. Very cool, right? Yeah, I know it's cool. Shut up. Now, what we need to do next is somehow change the speed of the ball, because that was kind of slow. How we can affect it? We could type multiply by some value like 4. Now it is faster. Yeah, very good. But what if we want to control this value? What if we don't want to go every time to script and change 4 to 6 if we are not happy with it? For that, we can create a new value, public float, that I'll name as move speed. And now, instead of 4, here I'm gonna type move speed. Okay, very good. Now look, we have move speed 0, and ball will not move, because multiplying by 0 gives you 0. But if you increase value to, let's say 15, you can move. Very good. We can make it smaller, like 5, and make a couple of platforms. And now we have platformer. Yeah, but we cannot jump. How we can jump? Well, that is very easy task. Actually, we did input of a jump before, right? We did, if you remember, if input dot get key down key code space, and then we did debug of the debug log jump. And if you remember, in the beginning of this video, I showed you how to launch the ball up. So try to do that, and I'll just wait a couple of seconds to give you this as a challenge. Try to make your ball jump now. All right, I'm gonna count 1, 2, 3. Okay, so how we do this? Simple. rb.velocity equals to new vector 2. We're not gonna change velocity on the x, rb.velocity.x, and for the y, we're gonna give it a value. And I wanna use adjustable value, so I'm gonna make public float jump force. Okay, and I'm gonna do here jump force. Yeah. Okay, so that's what we have. We have input of a space, and that will make velocity for the y, and we have controls that allows you to move left and right. Let's go and see this. I'm gonna increase move speed to 4 and jump force to 7. Just throw in values. You can use any values you want. I'm gonna save it and go to play mode. Okay, so I can move left and right, and I can jump. Not high enough though. Also, you can notice that if you press jump lots of times, you actually can fly, which is not behavior that we want. But we're gonna fix it later. For now, this is good enough, and let's go to next video. We're done here. Hello guys, in this video I just want to start a good habit, a good practice of a clean code. Actually, clean code is the last thing you should be worried about when you just learn in Unity and learn how to code. This should not bother you, you should focus on other things. But there are some minor aspects that you can remember that will make your life easier later, and you don't have to reteach yourself when you know how to do things right. And I'm talking about making values private and exposed to inspector. It's a good practice to keep values private by default and make them public only if you really have a reason to do that. And at the moment we have some of the values public. We do that because we need them to be exposed in the inspector so we can change them. But actually we can make them private and still make them available in the inspector. Let's make a private float move speed, and let's make private float jump force, and let's make rigid body private as well. So now if I save my script, I cannot see them in the inspector anymore. But what if I need to? What if I want to change move speed? For that we can use feature that is available in Unity, and that is a serialized field. Just in the beginning over here, we can type serialized field, and here as well, serialized field. Now when you save a code, you can go to Unity and you can see your values. You can change them if you need, which is really cool. And about rigid body, there is no really a reason to make it visible in the inspector because we assign it only one time. But still somehow we need to assign it and keep it private. So to do that, we can just get a component. If we go to start function and type here rb equals to get component of rigid body, this script will check all of the components that is attached to this game object, and if there is a rigid body, it will assign RB to rigid body. So now this RB is still very same rigid body on the player. You can check that by going to debug mode over here. You can see RB player, and this player is selected. But it's not visible in the inspector and it's not public. Cool, right? Well, that's it for this video, and from now on we'll try to make values private. If we need to see them, we're gonna type serialized field, and we're not gonna make them public unless we really need to. Alright, that's it for this video. See you in the next one. Hello guys, in this video I want to make our player look like a player, not like a yellow ball, and for that we're gonna use sprite sheet that we dragged before. We're gonna cut it. I'm gonna explain how to cut it and what settings you should set before you use pixel graphics. And later on we're also gonna talk about pivot point, but that will come later. Let's focus on making it look like this girl. So at the moment my sprite sheet looks like this, and I cannot use it in the game. That is not okay. So first what I need to do is to cut it, and I can cut it by setting sprite mode to multiple. Now normally you would click apply to apply changes, but I want to show you a little trick to make your work faster. In any case, after you setting it to multiple, you're gonna go to sprite editor. And if you go to sprite editor without clicking apply, it will offer you to apply settings. So you kind of save yourself a couple of seconds on hitting extra button. You know what I mean? Like multiple, apply, and then sprite editor. Or you can just do multiple, sprite editor, apply, and you saved yourself a couple of seconds. That's what I like to do. Now we need to slice it. How do you slice it? You go to slice over here. There are couple of ways to slice it. Can be automatic, can be by cell size, cell count, and we cannot use automatic now because this sprite sheet is not really good for that, because there are different sprites with a different size and different position of the character, so that is not okay. I'm gonna show you the ideal sprite sheet later. For now, let's cut this one. So if I click grid by cell size and choose pixel size on the X 69 and on the Y 44, it will be the ideal size that we need. And now we have a bunch of sprites that are separated from each other that we can use. All right, let's hit apply, go back. We can click this arrow and we can see a bunch of sprites now. If I drag one of them to the scene, we can see there is an object that we're gonna use, but it is kind of small. To fix that, we're gonna select the sprite sheet and change pixel per unit. We're gonna change it to 16. Let's hit apply. Now we have a proper size. With only difference, it is blurry. The image is not sharp. To fix that, we're gonna select the sprite sheet, choose compression to none, and filter mode to point no filter. Now if I hit apply, we can see image became crisp and sharp, just as we need. Now, I don't want to have a new object for this one. I want my player to look like this. So what we're gonna do here is to delete this one. We're gonna select player and we're gonna drag the sprite over here to circle. Now, a couple of problems here. First, we can see it's yellow because we did change color. So let's make it white. All right, now it's fine. And the collider of it is not okay. And actually you can see that center of the object is not in the center of the character. That is happening for a simple reason. Again, it is because of how a sprite sheet is set up. In here, you can actually see your sprite is on the left of the center. And we could change the center by moving this pivot point somewhere here, but this is not what I want to do for all of the sprites I have in the game, because sometimes it should be there, sometimes it should be there. That is not okay. We have another way to fix this issue. Before we do that, I want to show you how ideally sprite sheet would look in another game. For that, I'm going to open my another project for another game we created in the course on how to make platformer. So in this course, I've used sprite sheet with different characters. And as you can see, all of them is separated by action. So one sprite sheet for one animation: run, wall jump, there is an idle, hit, and so on. And you can see they all even in size, 32 by 32. And you can see that center of the character is basically set automatically for each sprite. And this is kind of perfect. This is what I would like to see in every my project. But life is not so good. And sometimes we as a developer receive different kind of graphics set in a different way because there is a like, you know, millions of people that were taught in different way or doing things in the way they like. For example, another project I had in another course on how to make Endless Runner, all of the sprites are set like this, as a separate image, which is also okay, which is convenient to work with. You can edit each sprite as you need, but at least they all even in size. And let me find another animation. Yeah, at least they all even in size, so I know what to expect from it. But in this spreadsheet that I'm using right now, sometimes character is on the left, sometimes not, which is, I would say, not ideal. But doesn't matter, it's not impossible to work with, it's just set in a different way. It's totally not bad, it's okay. So I'm gonna hit apply here, close it, and now somehow I need to center my character. For that, I can separate a component of sprite renderer to a different object. How do I do that? I'm gonna create empty that I'm gonna name as, how I'm gonna name this? Let's name this as animator, because later we're gonna have animator on this object. And now I'm gonna delete component of a sprite renderer from here. My object is invisible now, and we clearly can see what is the center of the object. Now I'm gonna take my animator and add component of a sprite renderer. And then I'm gonna drag my sprite here. And still, it is not in the center, but we can fix it. We can fix it by slightly changing position of the child object. So this is a child, this is a parent. And if we change position of a child just a bit to the right, then we select the player. And we need to go here and choose pivot point. Okay, let's change it here from center to pivot. And now we can see that my center of the object is kind of in the center. Let me just fix it a little bit more, maybe a bit to the left. And it's okay. This is center of the character. Don't worry if it doesn't look like mine exactly. It should not be a perfect pixel to pixel center point, just should be somewhat in the center. And it's fine. That is enough for us. And now we need to change collider because circle is not okay. If I go to play mode right now, this is how it's gonna look. Boom. Not cool. So what we can do here is to delete circle collider, and we can add a capsule collider 2D. Okay, now we're gonna increase the size of the collider. Yeah, this is better. This is better. This is what we need. And as you understood by now, I guess, let me move it here. Yeah, as you understood by now, I guess, it doesn't matter where your component is. We can place component as a child of the object and put a look of the character on a different game object, and still it's gonna work as a whole, as one object. So now if I go to play mode, you can see I can move the character. Oh no, fell down. Yeah. And it moves together, even though my script sits on the parent and my look of the character sits on the child. Now let's fix this falling on the side. We can go to player, rigid body, freeze rotation Z. And while we are here, let's change collision detection to continuous and interpolate to interpolate. Okay, now we have a hero who can move left and right. We only need to make it animated, and we're gonna do that in the next videos. Let's go and do that. Hello guys, in this video we're gonna make our character animated. It's gonna be easy task, even though animator is a bit complex to understand at the beginning. In general, it's a very simple tool to work with. So what we need to do first is we need to go to Window, find Animation. We're gonna drag this window over here. We're gonna use it later. And we're gonna go to Window, Animation, Animator, and we're gonna have it here. Okay, so Animator takes a bunch of sprites that you give it and place them in a certain order to make animation look like an actual animation. So first, let's create an animator. We're gonna click right button, create animator controller, player AC. So as a player animator controller, we're gonna drag it on the animator object because we have sprite renderer here. So we need to animate this object, not this object. This object doesn't have any sprites on it. If I switch it off, it's gonna be invisible. Yeah. But if I switch off this one, everything's gonna be switched off. Okay, so we have animator. Now we can create an animation. Let's do this. Let's click create. In the assets, we're gonna do player idle, and we have player idle animation. Now we need to drag some sprites to this animation to make it work. I'm gonna go here, find my idle animation, and it looks like it's from first 1, 2, 3, 4, 5, 6 sprites. Let's take them all and drag them to animation over here. Now if I hit play, it's going to be very fast, but it's going to work. If I change sample rate to 12, if you don't see sample rate here, you can click these 3 dots and click show sample rate. It's going to show sample rate. So 12. And now, without even doing anything, if I go to play mode, we can see our player is animated and she's breathing, she looks more alive. But if I move, magic will be ruined because run animation is not working. Yeah? Yeah. So how do we make run animation? First, we need that animation. Let's go select animator. Then we go in here, click create new clip. Player move. We're gonna go to sprite sheet, find movement animation, and this one looks like it. So we're gonna take them, place them, and sample rate will be 12 again. Should be fine. Kind of fast, but it's okay. You know what? Let's try 10. I guess 10 will be better. 10 here and 10 here. So now we have move animation, but if you go to play mode, she's gonna stand in the idle. And if you go here to the animator of the player, we can see that idle animation is an orange color, which means this animation played by default. Yeah, it is, let me place it here. It is played by default and there is no transition to another animation. It is there, player move is here, but there is no connection between them. And that is the problem we need to fix. Now, how we can do that? First, we need a parameters that will say if we actually can transfer to another animation. What is a condition? Why we should transfer? What condition should be met to transfer to another animation? For that, we go to parameters, click plus, we find bool, and we type here is moving. So this is the name of our parameter. And now let's make transition. We're gonna click right button on the idle, drag it to player move, select it, and there is a conditions on the right. We're gonna click plus, and from idle to move, we transfer if is moving true. Now let's make another condition, make it back. Now condition should be is moving false. So if moving false, then we go to idle back. Very simple stuff to set up, very simple stuff to understand. Now, as we controlled velocity of the rigid body before, somehow we need to control this parameter of the animator, because we have animator in the object, but we have no control of it. We kinda need a remote. How we can do this? We can get access to this animator, exactly this one, in our script of the player. Let's open this. And again, as of now, I'll just type public animator. I'm gonna name it as anim. Let's go back. Now look, we have anim, which is empty. And if I drag my animator here, it's gonna be assigned. Now by selecting it again, just by clicking it, I can find it. And this is the one. This is the animator that we control. So this animator here is assigned to this animator over here. This is the same thing. And this animator is exactly this animator. And both of them assigned to this anim over here. Now we know what we are assigning, and I guess by now you understand how and why we are assigning stuff. So I want to make it private, and I want to assign it through getComponent. So I'm going to make it private, but instead of getComponent, I need to type something different, because animator, I'm sorry for me switching it back here and there between the windows. So here, player doesn't have a component of the animator. Component of the animator is actually on the child object of the player here, which doesn't have any script on it. So we need to get access of the animator from the child. That's what we're gonna do. Anim equals to getComponent, but this time we type in children. And what type of component? We need animator. Good, this is what we did. We have access to the animator. Now there is something we need to do. We're gonna go over here below the jump input and type anim setBool, and that is a boolean that we have in the Unity. Over here, this is the parameter. If you don't know what is boolean, it's something very simple. Boolean can have only two states, true or false. This is how you create it, private. Boolean is moving, and it can be only true or only false. That's it, very simple. Is moving, true. Or is moving, false. Now let's go to anim setBool and type name of the boolean we're setting. If you put your mouse over setBool, you can see what it asks. It needs string name and then boolean value. So the name of it in the Unity is moving. Is moving. And value we're giving is moving. Okay, I actually want to make this public so we can click it in the inspector. Oh, let's make it just serialized field, why not? Now, if I go to my play mode, I can see it is in the idle. If I select player and click this boolean is moving, and if I make it true, we have is moving true here, and character is moving. So this boolean is equals to this boolean, because we set it in the code, so that's what we said. Is moving, we set to is moving. Now, obviously, we cannot click is moving with our hands every time, right? We don't actually need a boolean like that. So what we can do is to say is moving equals true, and it will be true only if rbVelocity.x not equals to 0. That's how you do it. Another way would be to, like, more intuitive one, I would say, to type if rbVelocity on the x is not equals to 0, it means it is either -1 or 1 or bigger value, then is moving true. Else we said is moving false. But that is kind of a bad practice. You already can see how much more of code it is. And if we type something like this all of the time, it will make a mess in the code. So we don't need it. We can type just is moving, save it, and then go to Unity. Now, if I'll move, I'll set velocity of the rigid body. I can see that by going to info over here. It has velocity on the x. And if I move, I have velocity not equals to 0, and I have animation played, which is cool, right? Yeah. Now, you can see there is a bit of a delay between animations. If I go there, if I click run, she stands for a bit and then she moves. To fix that, we need to go to transition over here and uncheck has exit time, and transition duration should be 0. And this basically default settings that we're going to use throughout most of the animations. Only in some cases we're going to have exit time. Okay, and here exit time uncheck. Now if I go back to play mode, you can see me activating animation instantly when I move. Of course we need to flip the character, but it's going to come later. For now let's just focus on this. So animation works. That is cool, right? This is what we need. Hello guys, in this video I want to do a bit of changes to our code and to our project. I just want to do a bit of a cleanup and nothing special, nothing much, and I actually think I could do it in the last video, but I decided to put it in the separate video so it's easier for you to navigate if you want to find some certain thing around the course. Yeah, so let's do a bit of a changes. For that, let's go back to our code. So first what I want to do here is to create a function for control of the animations only. So you can create a function. I'm going to name it private void animator controllers. Then I'm going to take this code, I'm going to hold my Alt key and press arrow down to move it down, just like this. Okay. Now I have this function which controls animation, but it doesn't work. You can see it's not highlighted, it's not called from anywhere, and even it says 0 references over here. To make it work like before, we just need to write it in the update, animator controllers. Save it. So now we have this function which is called all the time, and what is inside of this function will be called together with it. So it's basically like like a container, like a references for easier navigation around the code. Later we're gonna have more functions in the update to make it easy to understand for us what does what. We're gonna separate them into different small functions. Now I want to do a bit more of a cleanup here. I want to separate other things to in other functions, so it's easier for us to navigate later, and it's easier for us to change something if we want to. You'll see what I mean when we're done with this video. You'll see. It looks much better. So I'm going to select line of code that is responsible for jump. I'm going to do that by holding Shift and clicking Home button. And then I'm going to click Alt plus Enter to call submenu, just like this. And I'm going to find extract method. Now method is extracted, and I'm going to name it as jump. So this is a jump function now that contains code for jump, and we can see if we do input of a key code space, then we call jump. And even with this example, you can see what I meant by making it more clear and readable. Now it's obvious we do jump, and if we want to know some details, we can click right button and go to definition and find what jump function does, which is much more easier to navigate around and control. Now on that example, I'm going to select this line of code. I'm going to click Alt Enter to call submenu. I'm going to extract method, and I'm going to name it as movement. Okay, this is cool. Now something else I want to do here. I want to move this line of code on the top. I'm going to do that by holding Alt and pressing arrow up like that. And I want to create another function for inputs. So I'm going to select all of these code, click Alt Enter, extract method, and I'm going to name it as input, or maybe even better, check input. Okay, so now our update is clean. We know we have movement function, we have check input function, and we have animator controllers function. If we want to know some details, we can do that. We can go to check input and see what it does. It sets X input to get axis row. If we do input of the space, it does the jump. Movement controlled with the X input and move speed, and jump controlled with a jump force, and animator controllers do control animator. I want to do some additional changes here to make it look even cooler. So actually, is moving boolean used at the moment only here in the anim set bool, nowhere else. And we don't need it nowhere else at the moment. So what we can do is to delete it from here. And here we can create a temporary, it's very difficult for me to spell, temporary value,
Temporary.
So what I mean by that, we can create a temp value that will be available only inside of this function. We can create variables here. Bool is moving equals to blah, blah, blah. And you can see it's highlighted in different color. It means it is available only inside of this function. It is private to this function. So if I go to jump function, for example, and if I want to type is moving, IntelliSense will not understand me because there is no such thing available in the code. Unless we go here, is moving. Here it is available. Very cool, right? Yeah. Well, that's it for cleanup here. I'm also going to delete these green lines of code. We know that update is called once per frame and start is called before the first frame. So we're going to save it. All, this looks better. Now we can go to Unity and do cleanup here as well. I'm going to create a folder, graphics. I'm going to drag my sprite sheet to graphics. I'm going to create a folder, animations. I'm going to drag my animations and animator controller there, and inside, well, we don't have as much files now, so we don't need to arrange it. Let's keep it like this. And this looks much better, easier to work with. Now we have clean project here. We have clean code here, and we can jump to next video. Let's go and do that. Hello guys, in this video I wanna solve a problem, an obvious problem that we have currently in the game. And I'm talking about flipping the character, because now I'm running backwards, which is not cool. I'm gonna explain how we're gonna do this. Gonna be super simple to do. Look, we have a player and we have rotation of the character. Actually, even though we see things in 2D now, the game itself exists in a 3D space. If you click this icon, you can see how things are 3D here. To navigate and rotate like that, I'm holding the right button, so I can see my objects there in 3D. And to flip the character, we're gonna flip rotation on the Y, like this. So we're gonna turn it so it's looking to the left. But we're gonna do it real fast, and in 2D mode, it's gonna be unnoticeable. It's gonna look like this. You don't look what I do here, you look how it looks here. That's what we're gonna do. Or even faster. Okay, so this is the task, but we need to do this in the code, which is super simple. Let's go to player, and we're gonna create a function, private void. We're gonna call it flip. Inside of a flip function, we're gonna type transform, and transform is exactly this component, transform. We're gonna do transform dot rotate. We're not gonna rotate 0, we're gonna rotate 180 on the Y, and we're not gonna rotate Z. This is what we're gonna do. And there are some more to it, but for now I just want to check how it works. So let's go to update and type if input dot get key down key code R, then we're gonna do flip. And by the way, in the if statement, if you have only one line of code, just like here, you don't have to type curly brackets. So it can look like this, or it can look like this, and it's gonna be the same. So this also will work. But if you have another line of code here, you must put curly brackets. I mean, in the if statement. Okay, let's go. So I'm gonna go to play mode, click the R, and I'm flipping. So this is how it should feel. By the way, I'm flipping it now manually. We did not write code to flip it automatically. I'm just clicking the button. This is how it should be. Now let's make it automatic. To make it automatic, first we need to know what is the facing direction of the character by default, and we need to know if character actually facing right at the moment. So let's go above here and type private int An integer allows you to store numbers just like float, but integer cannot hold a decimal. So it's either like 1, 2, 3, 4, but not 1.5. It cannot store a decimal. That's it. So we type private int, we name it as facing direction, or we can just type facing dir to make it shorter, and we can give it a default value. Our character by default looking to the right. So we're gonna type here facing dir equals to 1 by default. This is the default value. And we need private bool facing right. So we know if player facing right. And by default also it's gonna be true. Yeah. Now when we set character to look to the left, we're just gonna do not facing right. Very simple. Let's go back to our flip function and type here facing dir equals to facing dir multiplied by -1. So when we use in flip function, we're gonna make facing direction not 1 but -1. When we do flip again, it's gonna be 1 again, and then -1, 1, -1, 1. We need this value later so we can set different like skills or abilities or movements according to the facing direction. So basically now we're just preparing base for the character. And then next one is facing right. Facing right. We're gonna make it equals to not facing right, which will act as a switcher basically. Just think about this. Facing right equals to true, and we make it equals to not facing right, which is false, which will become false now. Now, if this false, we make it equals to not false, which will become true. If it's confusing, just think about this as a switcher. This works as a switcher between one boolean, true, false, that's it. Now we have this information and we're gonna use it for automatic flip. Before we do that, let's make sure it's working. Let's go back. I'm gonna go to debug mode. Now I can see facing direction and facing right. I'm gonna go to play mode. We can see it's 1 and it's facing right and it's true. And if I click R button on my keyboard, facing right, false, facing direction, -1. Good, right? Yeah, I think so. Now let's go back to code. And we make a function flip controller, private void flip controller. In this flip controller, we need to make an if statement. That's gonna check if RB velocity.x is bigger than 0, it means character moving to the right because velocity is positive, and when velocity is positive, you remember vector 2. When velocity is positive, it means we move into the right. When velocity is negative, we move into the left. So if we move into the right and we are not facing right, then we need to do flip. And we do flip function. Then we do else if, which allows you to do another option. If was not met, then we can check else if another condition, RB velocity.x less than 0, we move into the left and we facing right. We need to fix that. We need to do not facing right because we move into the left. Then we do again flip here. And that's it. And this function, as you can see, not highlighted, it's not working. So this if statement won't work unless we make it work. When we're gonna go to update over here and just type flip controller. Okay, now let's go back. I'm standing, I'm moving to the left, and I'm flipping. Yeah, how cool is that? Tell me. Really nice. Now we have more issues to fix, like a jump, for example, right? We need animation for a jump, and we need to make it less floaty, more snappy, but we're gonna do it later. For now, for this video, we did a great job. Let's go and do a small cleanup. If you remember, I told you that you can write if statement like this, And by the way, we don't need this if statement. And in the flip controller, I can just type if, then flip, else if, then flip. It's just something like my preference, my personal preference. I like to do it this way, but if you like, you can keep curly brackets, nothing wrong with it. Works the same, just looks different. Okay, thanks for attention, and let's jump to another video. Hello guys, in this video we're gonna fix another obvious problem we have in the game, and that is endless jump. Currently at the moment I can press the space button to jump, but if I do it again, I can basically fly. So we need somehow to stop this behavior, and that is a very easy to do. I'm gonna explain how it works first. So we need to make a condition for a jump. Jump should be available only if some conditions are met. And what condition could be met for a jump? I say we should do jump only if player is on the ground. So how we do that? We're gonna do a ground check. Super simple. To explain how it's gonna work, first I just wanna draw a gizmos. I wanna draw a line to show this ground check, and then we're gonna do actual ground check. So let me do this. We're gonna type serialize field, private float, ground check distance. Now we're gonna go all the way down and draw a gizmos. This is easy to do. We just type here on draw gizmos. This is the function that used to draw gizmos. And inside we're gonna do gizmos.draw line. And don't worry if you won't remember this at first. I came back to see how gizmos is drawn for, I don't know, first maybe 5 months of me making games. At the very first beginning, I remember for some reason it was difficult to remember. So when we draw a line, we need to know from to, as you can see. We draw it from transform position, and we draw it to vector 3. We're gonna do new vector 3. On the x it should be transform position.x. On the y it should be transform position.y, and because we draw it down to the ground, we do minus ground check distance. And we don't need a z, so we can just close it with a semicolon. You got what we're doing here? We have a position of the player, transform position, and we draw a line to a certain point. And what is the point? The point is x of the player, and y of the player minus ground check distance, the amount we're gonna set later. So if we don't change an x and just do minus y, we draw a line like this. Yeah, let's go back now. We have this ground check distance. I'm gonna increase the value, and there is a line you can see. You can see the line, right? White line. We're gonna use this line to detect ground below us. So if this line will touch any ground, then we will be able to jump. I'm gonna decrease the value and make it like 0.4. Yeah, this is okay. Now let's go back to code. We know how the line looks. Now let's use it. Somewhere here we can make, first we need a layer mask. So let's do a layer mask, serialize field, private layer mask. We need a layer mask so we know what is actually a ground, what is actually a player. We can separate them to different layers. What is ground? And we need a boolean that says player is grounded. But this can be just private. Private bool is grounded. Cool. Very good. Now let's go to update over here and say that is grounded equals to physics2d dot raycast from origin and direction. So origin is transform position, and direction is vector2.down. Now we need a distance that is a ground check distance, and we need a layer mask that we created. What is ground? Now I'm just gonna debug is grounded, so we can see what it does. Let's go back to Unity. We have a layers over here, and we need to create a layer for ground. So we click add layer. I'm gonna name it ground. Now I'm gonna select my platforms, 1 and 2. Let me place it here. So 1 and 2, layer, ground. Now we're gonna select the player itself, find what is ground. At the moment it's set to nothing, so we do ground here. So we created, if you remember, we created a layer mask. This layer mask is ground, so it detects only ground, and our platform is set to layer ground. Let's go and do this. We have a debug that says true, 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 true. If I jump, it's gonna say false, 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 because this line does not detect the ground. Very cool. Now, going back to code, I'm gonna delete debug. I'm gonna go to jump function, and I can say that this can happen only if it's grounded. Just like this. Super simple, right? Now look at this. I'm gonna jump, and I can jump only once. Only when I'm on the ground. Perfect. Now let's do a bit of a cleanup in the code. First, I wanna separate this into another function. I'm gonna click Alt-Enter. Extract method. And it's gonna be collision checks. Okay, cool. We have collision checks now, and it's in the update. It's called all the time. Something else I want to do to make it look better is to make a header. At the moment, we can see our script is short. There is not much variables now, and we can navigate through it. But later it's gonna have more values, like let's imagine just it has a damage, HP, mana, I don't know, length of a dash, cooldowns, so many variables. So we need to make it look pretty and cleaner. How we can do this? Let's go to player now and create a header. First, I will move this boolean below, because otherwise header won't work. And I'm gonna type here header collision info. Now I'm gonna save it. And in the inspector, it looks like this. Move speed, jump force, collision info, these two. Much easier to understand. Something you should know, which I didn't know at some point, if after header you have a private value which is not exposed to the inspector, header won't work. So if you want header to work, you need to have serialized field after the header, or you need to have public value. You see? Not working. Good. Let me put it back, save it, and we can go to another video. Hello guys, so next problem we have to solve is a jump animation. At the moment, if I jump, it looks like this or like this, which is not cool. And first step to the solution is to create jump animation itself. Let's go to animation window, select our animator, and click create new clip. I'm gonna go to animations folder and type here player jump. Now we're gonna go to graphics, find our sprite sheet, and find the sprites for jump. And these they are. These 41, 42, 43. We can take them and drag here and make sample rate 10. Yeah, that's okay. Now we have jump animation in the animator, And we're supposed to transfer to jump animation from anywhere. It doesn't matter if character is idle or if he is moving. If he jumps, we need to transfer to animation of the jump. So we can use this any state here, make transition to player jump, and condition for that should be player is not grounded. We have already said that in the last video. We just need to create parameter now and use it. Let's go and create boolean is grounded. Now let's go to condition and choose is grounded. We can see that is moving is first in the list here and here. So in the future, if we create in a new condition, we just drag it here to the top and it will be first in the list all the time. Now is grounded should be false for us to move to player jump animation. Let's make transition duration 0. And then we're going to make transition back to idle if is grounded true. Let's uncheck exit time and duration 0. That's it. Now we need to assign this parameter in the code because nothing is controlling it at the moment. So let's go back to the code of the player. I'm going to find my animator controllers function. And inside, we're just going to type anim set bool is grounded to the value of is grounded. Now going to a play mode, we can see how it will work. I'm gonna jump and I'm jumping. The only problem is there is no falling animation at the moment, so it looks fake, I guess, right? Not cool at all. And it's kind of not animated. Give me a second, I want to double check that. Should be animated. Did I miss that? Okay, to fix this, we can just go to animator, find the transition, and uncheck this can transit to self. Now it's better. Yeah, so we have it working, but it's not the final product because we need to make a fall animation and somehow we need to make a transfer between rising animation and falling animation, right? So what we're gonna do here is to select animator and create new clip, animations, player fall, sample rate should be 10. Then let's go to graphics and find falling animation. It is these 3 sprites. So from 46 to 48, drag them here. Let's check this. Yeah, this is okay. And now I want to show you a trick. Instead of player jump and player fall animation, we're gonna use something new. If this is your first or second game, very high chance you didn't see it before. We need to click right button, create state, blend tree. Together with the blend tree was created a parameter. The use of this parameter I'm gonna explain in a second. For now, let's just rename this to jump fall. Huh? Why? Oh, I know, it's a glitch with Unity. I've seen it before. I'll try again, jump fall. 10. Okay, I need to restart Unity real quick. Now I'll try again. Should be fine. Jump, fall. Okay. Now I'm gonna do double click on this one. And here we can add motions. 1, 2. First motion will be player fall, and second one, player jump. We're gonna uncheck automate threshold over here and set fall to -1. And we have this blend parameter, which we're going to rename to Y velocity. Now, to explain what it gives us, I'm going to drag this window over here just up. I'm going to select. Yeah, we need to select our animator, then blend tree. And yeah, if it didn't show to you like mine was, just select animator and then select blend tree and it's going to be fine. So we have a window here. If we go to play mode, over here, we can see animation played. And this Y velocity will blend between animations according to its value. If I increase Y velocity, you can see animation shows as a rising animation. If I decrease it to minus, it's going to be falling. So this will do automatic transfer between animations according to y velocity we have on the character. Now we need to connect this blend tree to other animations. Let's do transition to jump fall. Again, if we can close this now, we don't need it. If grounded false, duration 0. This is the settings. Now we're doing transition back to idle. If grounded is true. Exit time uncheck, duration 0. And before we test this, let's assign y velocity to velocity of the rigid body. We can do it in the script. Over here, I'm gonna, maybe at the top, I'm gonna do anim set float of the name y velocity to rbvelocity.y. Very good. Now let's save it, go back. And go into play mode, I'm sure it's gonna work. Now I'm running, I'm jumping, and I'm falling. The only show animation is not played, and let me see why. Maybe because of the can transit to self. Let me uncheck this one and test again. Yeah, this is better. Now we need to make player jump faster. Okay, so you've got why there was only first frame played. If we go to settings and uncheck and transit to self, it's gonna be fine. No frozen animation. Now let's make our player's movement more snappy. For that, I'm gonna go to rigid body and increase gravity scale to 3.5. Maybe more jump force, like 12. Yeah, this is better. Now let's increase move speed to something like 8. We can work on the values later. For now, it's okay, I guess. Now we have this issue of player sticking to the wall, and we're gonna fix that later. For now, that's it. For this video, we are done, and I'll see you in the next one. Hello guys, in this video we're gonna fix a sticky situation we've got. I mean this one, that we stick to the wall. I showed you kind of a solution before. I mean, we just need to create a 2D material, and I showed you how to do that. So basically we're gonna go to 2D physics material. I'm gonna name it as Sleepy Mat, as for sleepy material, and I want to create folder for materials as well. Material, sleepy material. Then I'm gonna take my player and drag it to rigid body. Now she's not gonna stick to the walls. Oh yeah, of course. We need to open this material and we need to change friction from 0.4 to 0. Just like that. She's not really jumpy. Let me fix jump force and try this. Okay, so we're not sticking to the wall anymore. Great. This is just great. Well, that's it for this video. Let's go to the next one. Hello guys, in this video I want to talk about timers. It's something we're gonna use later in the course. We're gonna use it, I would say, a lot, and I want you to be familiar with the technique that we're gonna use and in general how time.delta time works. It's a good knowledge that everybody should know when they work with Unity. Alright, so there is such thing as a time.delta time. It shows you time that passed between frames. And we can basically use it as a timer for cooldown or any other things. As an example, let's make a dash ability and we're gonna use timer for that. In order to make dash quick and snappy, you need to set the speed of a dash, how fast it is, and how long it lasts. So basically a dash duration. All right, and I want to begin with the dash duration. Let's create a serialized field, maybe somewhere above. And it's better create a header for that. Dash info, and then we're going to have serialized field dash, private float dash duration, and we need serialized field private float dash time. Now I'm gonna go to update and set dash time minus equals to time dot delta time. And this type of a writing would be the same if I would type dash time equals to dash time minus time dot delta time. They're both the same, it's just different way of writing things. So I'm gonna keep this one, and we're gonna see what's the value will be if we do minus time dot delta time from the dash time every update. Look, I have this dash time here, it is 0. I'm gonna hit play, and we can see value is getting decreased all the time, basically like a seconds in real life. And that's what we're gonna use for our dash time, for our dash ability, I mean. So now I'm gonna make that at the press of a button, dash time gonna be set to dash duration. Let's go to player. First, we're gonna say if dash time bigger than 0, then do debug.log. I am doing dash ability. We're just gonna debug a message. And then at the press of a button in the update, I'm gonna say if input.get key down, key code L shift, then do dash time equals to dash duration. All right, so what we did here, we decreasing the timer like all the time, every update, and at the press of a button, we set dash time to a positive value. So it's gonna, and it's still gonna be decreased, it's still gonna go to negative, just for some time it's gonna be positive for like a couple of seconds, and this will be time of our dash, and in that time we're gonna debug message I'm doing dash ability. Yeah, that explains it pretty well, I guess. So I'm gonna do dash duration. Let's say we have dash for 2 seconds. It is too long, but for the purpose of testing. So we have dash time goes to negative, like basically to infinity. And if I press my shift key, I can see I'm doing dash ability message for some time, and then it stopped. If you look at the time over here, you can see that it became 2, and then it goes to 0, and now it's not positive value anymore. 2, and it's decreasing, and that's how we're gonna do dash. Now, instead of debugging a message, we're gonna go to movement and say, if dash time bigger than 0, then we're gonna do rb.velocity equals to new vector 2. We're gonna have x input multiplied by, and we need speed for dash, how fast we're doing this dash ability. So let's go to dash and say, we'll make here serialized field, private float dash speed. Okay, where was that movement function? Here we're gonna do x input multiplied by dash speed. For the y we're not gonna change anything, or we're gonna, yeah, we can make a 0 here. Well, let's not change anything, rbvelocity.y. And then if dash time is bigger than 0, we're doing x input multiplied by dash speed, else we're gonna do a regular movement. Wait, let me make it a bit prettier. So this is how it's gonna work. And we don't need this debug anymore, we can erase it. Yeah, this is how it's gonna work. Now let's go back to Unity. We have dash duration 2 seconds, and I'm gonna set speed, move speed regular one gonna be 7, jump force 12, and dash speed 15. Okay, and dash duration, well, let's see how it works with 2. I know it's too long, but for the testing purpose, for a more obvious result. So if I'm pressing my shift key now, nothing is happening because we're multiplying dash by x input. And if I'm not doing any input, it is 0. We're gonna fix that later. For now, it doesn't matter. I'm gonna move to the left and click the shift. Boom, I moved faster. Well, I guess it's not so obvious. Let's make move speed 1 here and dash speed 15. Then it's gonna be obvious. Yeah. So 2 seconds is too long. Let's make 0.4. Now it is better. I'm gonna click Shift. So this is our dash. I know it doesn't look like dash, but we're gonna make it look like dash later. Now I wanna fix something here. It's kind of, I feel like it's not enough space here. So I'm gonna go to main camera. I'm gonna find size of the lens and I'm gonna increase it to something like 8. This looks better. I can see more now. All right, I'm gonna take these two platforms, move them here, and take this platform and make it longer. Oh wait, let's change the parameters. So dash duration gonna be 0.4, move speed 7, dash speed 15. So we can move, and if I click my dash key, I move faster. Now let's fix the animation for this one so it looks better. All right, we're gonna go to project. No, wait, we're gonna go to animation, select the animator, create new clip, animations, player dash. Let's save it, go to graphics, find our dash ability. I'm not sure how it looks, it's somewhere here. Yeah, this is the dash. That's what we're gonna use. So 69 to 72. Gonna grab it. I'm gonna set sample rate to 10. Yeah, this looks cool, right? Like a dash. Now we need to attach this animation to other animations. And how are we gonna do this? Let's do it from any state. Make transition to player dash. If is dashing, let's move it above, click condition plus, true, duration 0, can transit to self uncheck, and from there make transition to player idle. If is dashing, false. Same settings here. Okay. Let me make it pretty somehow. We have that. Now we need to set this parameter in the animator in the code. So we're gonna do that. We're gonna find animator controllers, and we're gonna try to do it a bit differently this time. I'm gonna do anim set bool of is dashing, and it's gonna be set only if dash time bigger than 0. This should work. So it's gonna be true only if dash time bigger than 0. Let's go back to the game. Yeah, so we have animation, we have a dash, looks pretty, looks nice. So we have one issue here. I can hold my shift and do dash endlessly without cooldown. Basically, I can fly. So we need to put a cooldown on this one. And how we can do this? Oh, did you see that? That is a bug. Well, so what is happening here with this bug, I'm gonna tell you. In the air, if I do dash, I'm doing transfer between, let's see this, between dash and jump fall all the time. You're gonna see it in the animator over here now. You seen that? Dash and jump, they do endless transfer. So what we need to do here is to add another condition over here. Is dashing should be false. Then we can do jump fall. Pretty simple. Yeah, this is better. And to improve it even more, we can put 0 on the Y velocity. So when player doing dash, he's not falling down. He's not losing his Y velocity. So we're gonna go back to code, find our dash over here, and set this to 0. This will work much better. Now look at this, I'm doing jump and dash, this is better. Now I can increase speed of the dash to make it faster and like more instant. I can increase speed to 25 and set 25 and set duration to 0.25, and it's gonna look differently. Check this out. It's fast and instant. But the problem of endless dash is not over. We still have it. But I want to do it in a different video, so it's easier for you to navigate around the course. So in this video, we did a dash ability that lasts for a certain amount of time with a certain speed. And now we can go and make a cooldown for dash. Let's go and do that. Hello guys, in this video I want to make an attack animation and attack ability for the player, but before we do that I just want to give you some information on what you should expect from this video and in general where this project is going. And also want to talk about importance of using state machine when you make it an RPG game. And the reason I'm talking about this right now, because this video would be a good example why you should use state machine and not write everything in one script. What is a state machine itself? I will touch briefly. I will not talk about it entirely. But yeah, let me explain that, and then we're gonna go on and make an attack animation and some other stuff before we jump to the main part of the course. First, state machine. What is a state machine? Actually, you already used a state machine without knowing it, and this is the animator. So animator basically is a state machine. Only one state at a time can be activated, right? And this is what we're gonna do later in the course with the script. We're gonna have each action of the character as a different state in a state machine. But as of now, we're using all things in one script. We have this bunch of a code, which is manageable at the moment. Right now it is okay. We know where is what, where is the movement, check inputs, collision, we can see everything clearly, but we still need to add some things to the player, right? Look, I'm gonna open Figma and I'm gonna talk a bit about things that we already have in the game, right? Let me make it bigger. So at the moment our character can move, he can jump, he can dash, and that's it, right? Only 3 movements. And we have this bunch of a code, this many. Now, what else we need to do? Well, I'm not talking about flipping and collision check, that is other stuff that we're not gonna touch. I'm talking about main actions of the character. What else we ideally want to have on the character? We want him to have attack, and we want him to have some combo attacks. So it should be like attack 1, attack 2, attack 3. We want him to have a wall slide ability, so he can slide off walls. We want to have wall jump ability. We want to have, let me think. Oh, sorry. I'm gonna make the font smaller. Maybe like this, yeah. So this is what we want to have. We also want to have a sword throwing ability that you might have seen in the trailer or in the gameplay video. Sword throwing ability. And we also, there is a skill tree that is represented somewhere here. I have it. We have this many skills, but that is way too complicated for the moment. Let's talk about simple stuff. This is very basic movement, right? And we can manage to do all of this in one script. We can manage to do that, but it's gonna feel a bit difficult to manage. You'll see what I mean by that when we start to work in this video on the attack and animations and so on. For now, just I want you to like get my idea. All right, so we're gonna create now an attack animation, and when I'm doing that, when I'm doing such a complex system in one script, I feel like I have a leaking barrel. So what I mean by that, let's imagine we have a barrel, right? So this is a barrel. And we have move, jump, and dash animation actions in this barrel. When you add an attack event, an attack ability, you need to make sure when you do an attack, you cannot jump, you cannot dash, you cannot move because character is busy with attack. So it's like one hole appearing that you need to patch somehow. Then when you add in another ability, when you add wall slide, you need to make sure when you're doing wall slide, there is no movement available, there is no jump available, there is no attack available because character busy with wall slide. So again, we need to patch things like this again and again. So that's how I feel when I add more functionality to the same script. You'll see what I mean by that once we start creating it, and we're gonna do it right now. And again, what I'm trying to say here, things will become, from this moment, things will become a bit complex and a bit difficult to manage. It doesn't mean it's wrong, it doesn't mean it's bad, it's just how it is when you write things in one script. But still, we're gonna do it for a couple of reasons. First, I want you to feel the difference between this one and when we're creating a finite state machine. Second one, that there are still some things that I want you to know before we jump to the main part. Like, I want you to know about inheritance and animation events and so on. So we're gonna learn it here. So when we do in finite state machine, you can focus your brain on learning what is a finite state machine instead of trying to understand what is the animation event he's talking about, or what is inheritance, what he mean by that. I want you to be ready, I want you to know the things so you can see bigger picture when we're working on finite state machine. All right, now let's do the attack. And while we're doing the attack, you'll see what I meant by drawing this barrel. All right, let's begin. Let's first create animations for attack. We're gonna go to animation, select animator. We're gonna create new clip, animations, and I don't want to have one attack. I want to have combo of attacks. So you can click mouse one time, or you can click it a couple of times and it looks differently. Let's do this. Player attack 1. We're gonna create new clip, player attack 2, and we're gonna create new clip, player attack 3. We're gonna 1, 2, 3. We have 3 animation of attacks. Very good. Let's leave them there for now. Now let's think about this. When we can attack, we should be able to attack. I'm gonna play the game. We should be able to attack when we're running or when we're standing, and not when we're jumping, because this is the attacks from the ground, if I'm not wrong. If I try to play those animations, we can see that. Oh, we did not set them yet. We'll set them now. Well, let's do it right now. Let's go to graphics. Sorry, I forgot about that. We're gonna find this will be the first attack from 15 sprite up to 22. So this will be the first attack. And let's make sample rate 10. So this is the attack animation. It looks like character should be on the ground. We cannot be in the air. Let's take a second one, sample rate 10. And we're gonna take these 4 sprites. No, these 3 sprites, I guess. Yeah. Let me see. Yeah, let's cut out this one. I don't want it here. So this is the last one for the first attack. And for the second attack, we're gonna move these 3 to the right and add this sprite here. So it looks like this. It looks like 1, 2, 3, 4 over. And for the third attack, I wanna go all the way down and find animation here. This meant to be a dash attack, but I want to use it as a third attack of the combo because it looks like a strong attack. Yeah, we're gonna take these sprites, put them here, make sample rate 10. Yeah, okay, maybe let's even add one more, this one. This looks better. Okay, so this is the third attack. Now, as I said, these attacks can be activated only when player is on the ground. So what we should do first, we should do transfer to attack from any state with the condition player is on the ground. So let's do this. 1, 2, 3. We're gonna set is grounded, should be true. Is grounded should be true. Is grounded should be true. And we're gonna add new parameter. Boolean is attacking. Yeah. Let's move it all the way up. Hit plus, is attacking true. Is attacking true. is attacking true. Now we need another condition, because there are 3 attacks, we need to transfer to a certain attack, like when we are at certain point of the combo. It can be a first attack, second or third. In programming, usually counting starts from 0. So we're gonna add a parameter integer that I'm gonna call combo counter, that it starts from 0. I'm gonna do first attack can be done if combo counter equals to 0. The second one if combo counter equals to 1. And third one if combo counter equals to 2. Now let's check exit time for all of them. 0 can transit to self uncheck. Same for this one. And same for this one. Now, next step would be to transfer back from these animations, right? And from all of them, we can go to player idle. So let's do it. Yeah, let's do it. I'm gonna place it here so it's kind of easier to see. Oh no, player idle set as layer default. Now make transition to player idle. Make transition to player idle. We're not going to have condition on the exit, but we're going to have exit time this time. We're going to set exit time to 1, transition duration 0. We need this so animation played once entirely and it's not interrupted. We need to make sure it's not interrupted because this is the attack of the player and we need to make sure it's played fully. All right, so we have exit time 1. Second one, exit time 1, duration 0. And here, exit time 1, duration 0. Now we all set in the terms of animator. Now we need to write a code for all of this to make it work. Let's go to player. First what we need is the input. And we need boolean is attacking. Let's create a header. Header attack info. I'm gonna do serialize. No, wait. We don't need public values for now. We just need header here to see things. I'm gonna do private bool is attacking. I'm gonna do private int combo counter. And I guess that's it for now. Now let's go to animator controllers. We set anim set bool is attacking to the one is attacking. Okay, and combo counter anim set integer of combo counter to combo counter. When you write these names, make sure they are the same as the name in Unity over here. Do not misspell it, otherwise it will not work. Yeah, so I will even copy this and paste it in here to make sure it's the same. Okay, so we set in parameters of the animator. Now let's actually assign these parameters. Let's make them true or false for any reason. So what we can do is we can do input if input dot get key down key code mouse 0, then is attacking true. And we're not going to touch combo counter yet. First, we need to work on exiting attack animation because we have some special way to do that. Look, is attacking by default is false. When I click my left mouse, it's going to be true. And there is no place where we're setting it to false. So now at the moment, I will be available to attack only once in the game in general. We can see is attacking boolean here. It is false, and my condition for transferring to player attack 1 is attacking should be true. So I'm gonna click the left button, boom, I attacked, and I'm not exiting the animation for some reason. By the way, I should have exit the animation. I have exit time 1. Oh yeah, of course, because we have is attacking true and we never set it to false. This condition is always met, so we go into player attack again and again. Now, how can we set it to false? We need to do it exactly when animation is over. And we don't want to do it with a timer. That would be too difficult to set up to manage. So what we can do here is to use animation event. Animation event allows you to attach a function to a certain frame. For example, we have this frame, the last one, and we can add event here. We don't have any function yet, I'm just showing it to you. And here we can add a function that will do whatever we need. And at the moment we need this animation to do isAttacking false. I mean, this function should do isAttacking false. Because animator is a child of an object player, it doesn't have any script yet. isAttacking boolean stays on the player script. So what we need to do here is to make a function, a public function that we can access from another script, from another place. Public void attack over, and here we say isAttacking false. Now we need to call this function from some place to make isAttacking false. From what place? From animator. To add some function to event be available, we need to make sure the script with this function sits on the animator. So we're gonna create a new script that I'm gonna name player anim events. I'm gonna drag it here. Now we have a script. What it's gonna do, it's gonna have access to player. So we're gonna create private player, which will be a component from the parent. So we do player equals to get component in parent. By the way, to type things fast, just like I do, you can see I'm not actually typing get component in parent. This is too long to type and I cannot spell it right sometimes because English is my second language. So what I do is I type get com in pair, and you see it gives me autofill options. So I don't need to type entirely everything. I just need to type a couple of letters from the word I want, and it will give me autofill and I can use it. That's why it looks like get com in parent, and I have the option there. Then I'm gonna do get component player, and I can click tab to autofill everything I see that IntelliSense offering me to do. Tab, the tab on your keyboard. Okay, so we have component of the player. Now we need a function, and this function can be private animation trigger. I'll just name it animation trigger. Oh, private void, I'm sorry, my bad. Private void animation trigger, and inside we do player. Then we get access to the function in the player, so player dot attack over, and this is the function we created before. If you click go to definition, you can see this function. So what we're doing here is we are assigning event animation trigger on the animation, and this event, this function, will call function from the player. So it's basically just like our way to get to the function. Yeah, let's go to player attack 1 now, find the event and click animation trigger here. It is chosen. Now it's going to be set to false in the end of the animation, and let's see how it works for us. Boom, only one attack. Cool, right? Now we need to make the other attacks work, and there is another situation we need to fix, a lot of situations we need to fix. Look, if I'm running and I'm doing attack, I'm not stopping. If I'm doing dash and I'm doing attack, I'm doing dash and I'm still attacking, so I can do this. So as you can see, there are lots of points in the code where we need to fix, or I mean, a lot of places where we need to add some conditions to make it work properly. And that's what I meant by saying I feel like it's a leaking barrel with a bunch of holes that you need to fix, because you need to fix a dash now, you need to fix walking in the time of attack, you need to patch these things up. And we won't have this problem on making a state machine, but we cannot jump straight to the state machine because there are some things that you need to learn before. Yes. Okay, it's enough for this video. It's kind of long, I see, so let's stop now, and in the next video we're gonna do
animation, we're gonna do combo counter, and we're gonna do fix some bugs regarding attack. I'll see you in the next video. Hello guys, in this video we're gonna do combo counter. It's actually easy to do. First, what we want is to change number of a combo counter, and we can do that in the code in the time when we finishing our attack. So at the moment we're done with attack, I want to do combo counter ++, which is just as same as if you would type combo counter equals to combo counter +1. Just another way to write it. Both of these lines are the same. So combo counter ++, and we have only, if you remember, 0, 1, and 2. So if combo counter goes above number 2, if combo counter bigger than 2, then we need to make combo counter 0. Yeah. This should work already. We only need to assign animation events to other animations. So let's go to animation. Animator, we're gonna find player attack 2, find the last frame, and add event animation trigger. Player attack 3, we need to find last frame and add event animation trigger. Okay, let's test this. Yeah, combo works. Some problem is you can see that when I do attack, if I walk around, if I jump and I wait, my combo still starts from the second attack. And if I run again here and there and do again attack, it's gonna be combo number 3, which ideally would be to start combo over unless you tap button a lot of times in a row. How do we fix that? We're gonna go to player. We're gonna make 2 values. One of them gonna be private float combo time counter, I guess, and another one private float combo time. Yeah, I'm gonna put it above, and I'm gonna make this serialized field so we can see it. Actually, we don't need to see it. We can just we can just set default value because it's not gonna be a big amount. So maybe equals to 1.3f should be fine. Yeah. Now in the update, we do combo counter minus time dot delta time. No, wait, combo time counter. Yes. And every time we attack, we need to apply that time to time counter. So let's go here and say combo time counter equals to combo time. You know what? Let's make this value visible so we can change it if we need to, because I don't know how it's going to be. So let's do serialized field. And then in the combo counter, we need to say if combo time counter is less than 0, if like combo time is over, then we set combo counter to 0. If combo time counter less than 0, then combo counter equals to 0. I don't like the name time. I feel like it should be some like combo window time or something. Time window, combo time window. Let's rename it all across the script, and we can do that by pressing Ctrl+RR. This is the hotkey, so it will change name across the entire script. Combo time window. Yeah. So if it's less than 0, then we set combo counter to 0, and we're gonna set this value to positive every time we attack. And just for the purpose of the experiment, let's set time to something bigger. Let's make 1, for example. So if I click buttons very fast, it should do a combo. If I click it once, we can see in the animator combo counter 1. Okay, it doesn't work because we call in this function only with animation. All right, so I'm gonna cut it out from here with the Ctrl+X, and I'm gonna paste it in the update. So it does check all the time. Or we can
We don't have to do check all the time. We can do check when we do an attack. So let's do it here. Yeah, okay, before we attack. Good. And let's go back. Combo time is 1. I can do combo. Now, if I'll do attack once, my combo counter 1. And if I attack now, I should see the first animation, the player attack 1. Let's go. Yeah, player attack 1. I'll run around, player attack 1. I'll run around, player attack 1. But if I click it many times, it's going to be a combo. Now it's up to you how long should be your time window for combo attack. I think 1 second is okay. Good, this is working. Now there are some issues we need to fix. This already looks messy. Let's create a function, extract method, start attack event, I guess. Now we have a bug, we have a glitch. If I dash, I can attack. I can move and attack. To fix that, we need to go to code, to a movement, and say if is attacking, then RB velocity equals to new vector 2, 0, 0. So we cannot apply any velocity. And here we're gonna do else if. So this is kind of like one place we have to cover, right? If I'm attacking, I'm not moving, which looks good. How about dash ability? Can I dash when I attack? I can, and this is how it looks. You can see that, right? So first we need to go to our dash ability and make sure we are not attacking when we're doing dash. Go to definition and say and not is attacking. You see what I meant by barrel? We have so many places to hold to make it work, to not make it fall apart. Like I had to fix dash, I had to fix movement, I had to fix so many things. And it's not because of lack of planning, it's all because it is in one script and we have to manage all of the things when we add new feature. So now I cannot dash while I'm attacking, which is good. And can I attack while I'm dashing? Well, not exactly, I'm stopping, which is okay. Also, know there is a bug when I do dash, I'm not moving if I'm not doing any input. So we can fix that by going to code, find the movement of a dash over here, and we can multiply it not by X input, but by facing direction. Now, if we stand on one place and we do dash, it will dash. Good. Now, I cannot tell if it was complicated for you because I'm, as an instructor on Udemy, have to think of all of the levels there are that can be as my student. Some of the students have zero experience, like totally zero. Then this might be confusing. Some of the students made a couple of games before and they see this and they maybe even see a better way to make this. But the point I want to say here is in any case, you should feel this becomes difficult to manage because we just added an attack here and we already had to add one if statement, we had to add a couple of rules to animations, we have to add another if statement to a dash ability, we had to add some counters, and we only added an attack over here, right? We only added an attack. Now we would have to add a wall slide. And when we're doing that, as I said in the previous video, we need to make sure you cannot attack while you're doing wall slide. You cannot dash while you're doing wall slide. You cannot jump while you're doing wall slide. You cannot move while you're doing wall slide. So there will be another bunch of if statements in the movement and another bunch of if statements in the jump as well. By the way, jump, let's see. I didn't check that. Wait, I'm gonna attack and jump. This is what happens when I attack and jump. When I jump and attack. So I need another condition here. Where is attack? Start attack event, go to definition. We need to make sure we are grounded. We can do if not is grounded, then return. Return basically returns from the function without doing anything that is after return. So if return is written, it means function will be finished at this point and whatever is below won't work. So now if we're not on the ground, we cannot attack. Yeah, we cannot attack and we are not slowed down. Cool. Well, very good. Very, very good. I like what we have here. I like how it goes. And I hope you understand my point here. Again, I want to say something important. If this feels a bit complicated to you, it's all right. There is a reason for that. It is a bit complicated. And I promise to you, once we start to work on a state machine, it's gonna feel much easier to manage. Much easier. Because we're gonna have like one script only that is responsible for attack, and there won't be any other code that will interrupt the attack. Or we're going to have only one script that is responsible for dash ability, so we won't have to block attack ability in the dash because there is no other script. You'll see what I mean by that later. We still have to go through this to understand the basics, to understand how Unity works, and to see and of course to see the difference between two approaches. All right, I'll see you in the next video. We're gonna discuss something important. See you there. Hello guys, in this video I want to discuss one of the main principles of object-oriented programming, and I'm talking about inheritance. I will try to explain what is inheritance. I will show you a small example of inheritance, and in the next video we're gonna use inheritance to make enemy and the player with one code. So enemy and the player gonna use one bunch of code, but they're gonna do different functionality. All right, so what is inheritance? Let me try to draw it first. Let's say we have a skeleton archer, and let's say we have a skeleton warrior, right? So we have a skeleton archer and a skeleton, wait, I'll type here, skeleton warrior, and I can just copy this. And we have a skeleton archer. Both of the skeletons have some of the functionalities that are the same, right? Both of them can walk, both of them can see the player, both of them can, I don't know, stand and look around and attack, both of them have HP, both of them have so many same things, and both of them are skeleton. So inheritance would mean that you create a class that is a parent that is named skeleton, and this skeleton has functionality like walk, like idle, like let me make it smaller size, like attack, and let's say walk, idle, attack, and they both have HP. So object-oriented programming allows you not to copy the same code and write it same code for warrior and same code for archer. It allows you to write code once and then inherit it from the object and use it at two different objects that have similar functionality. They still can have some differences. The main point is they have some similarities that we can use in our advantage to not repeat the same. On our example, let's say all of the objects in the game should find a ground below their feet, so they can walk or jump, right? And at the moment, we have collision check on the player. Where is it? This is the collision check. We have collision check on the player. In the next video, we're gonna create a skeleton, and this skeleton should have a ground check as well, so he knows where he can walk and where he cannot walk. And intuitive decision would be just to take this code, copy it, and paste it into Skeleton script. But the ideal scenario would be to make a parent script for both of them that is named something like entity, for example. So both entities detect the ground, player detects the ground, skeleton detects the ground. They're just doing it for different purpose. That's what inheritance is about. Now, how it works in practice and what is important things you should know about inheritance. In this video, you can just observe, you can just watch me, you just listen carefully what I say and try to understand what we're doing here. Okay, so I will create, let me switch off the player. I'll create 2D object sprite square. This will be just a square. Now I'm gonna create a C# script that is gonna be parent for all of the shapes. This is gonna be named as shape, right? Let's open this. I'm gonna do a public string named as a shape name. This is the name of the variable. And at the start of the game, this shape gonna do debug.log. Hello, my shape is, and we're gonna do plus shape name. So each shape gonna debug its own name. I'm gonna close all but this. Now look, I'm going to play mode and of course, I did not put script on the object, which is important. And shape name is square. So I see a message. Hello, my shape is square. Good. Now we want to have another shape in the game, let's say. So this shape is circle. I'm gonna move it here. And I want this circle still write a message, but with a different parameter. So I'm gonna create a C# script named circle. Now, in order, well, let me make it full screen. In order for this to be inheritable, we need to do some changes to it. As of now, you know, there is a private void, which can be used only inside of the script, and there is a public void, which can be accessed from different places on the scripts, just like we did a public function on the player when we did attack event. Function can be inherited from another place only if it's public, or if you want to keep it private but still you want to make it inheritable, you can make it protected, right? And to make it inheritable exactly, we need to type virtual void here. I will make it public. For now, I'll just do public virtual void. So we need to know only one thing. Virtual means it can be inherited from child from another script. Now, how you do inheritance itself? At the moment, actually, circle is already inherited from MonoBehavior. MonoBehavior is a Unity script that has bunch of functions, lot of things that are used for different purposes in the game that are very useful. Basically, this is what allows us to use scripts in Unity. And yeah, we don't know much about them because we don't really care at the moment. And as of shape inheriting from MonoBehavior and circle inheriting from the MonoBehavior, if we inherit circle from shape, we're not gonna lose anything. So now this is inherited from shape, and we can do here override. Let's type override, and we can override start function. Now this override start has a base.start. What is a base.start? Well, if you put mouse over it, you can see void shape start. So exactly this start over here. We can go to definition and see this very same function. Now let's see what happens if I go to play mode right now. I'm gonna open console. Oh no, wait, I need to put circle script on it. Circle. It has a shape name. I need to write it down, and it's gonna be circle. Now I'm gonna open console, hit play. And you can see I've got two messages. One of them, hello, my shape is square. Another one, hello, my shape is circle. If I click twice on these messages, I will be driven to void start on the shape, which is a parent script. If I click my mouse on the circle over here, I'll be driven to the same function. And this function of the circle was called from the override start over here. So that's how you use it. And to make it act differently, you can add some functionality after the base start. Basically, it's the same if you would get access to the script like this, shape, and then you would do shape.start. This is the same as here. Yeah, but this is what we actually do when we do inheritance. We type override. Now I can add another functionality that will allow me to make objects behave differently. So if this one would be a skeleton warrior that just do attack and melee, and this skeleton warrior then attacks in range, he would do something different, right? So let's do something different here. I'm gonna do debug log, and I am inherited from shape. Okay. Now I have hello, my shape is circle, and I'm inherited from shape, and we have hello, my shape is square, because this function has only one line of code. This function has exactly the same line of code in the look of the function start, and it has another line of code. Let's try to make some more practical behavior for this. For example, I'm gonna make a rigid body. I'm gonna get access to rigid body 2D RB. And in the start, I'm gonna do rb.addVelocity. Oh no, wait, rb_velocity equals to new vector 2. And we need some velocity. Let's make public vector 2 velocity. Yeah, and I'm just gonna do type equals velocity. Very good. So this is in the start. We added a couple of variables, and they will be available on the shape as well, because we typed them in the script that is inherited. We need to add rigid body to them. Let's select them both and click rigid body 2D. Now we have rigid body and we have rigid body. So both of them gonna have velocity, just they can have different velocity. For the square, I'm gonna add 10 velocity on the Y. For the circle, I'm gonna add 10 velocity on the X, so it goes to the right. Let's see this. You see, they flew to different directions. So this is what inheritance does. And actually, when you add some functionality here, that is called polymorphism, which is also one of the principles of the OOP. If I'll go back to my examples of skeleton warrior and skeleton archer, both of them can have attack. But then when you call attack function, you can do some override, and warrior skeleton will attack in melee, and archer will do a long range attack, which means they both have same function, but it acts differently. This is a polymorphism, which is also very useful, which we're also going to use. Now, something else to know about this, the last one. As you can see, we do virtual void when we want function to be inheritable, and we do override when we want to inherit the function. If you make it private, function cannot be inherited. I'm gonna delete this. Function cannot be inherited. If you type override here, you won't see start as an autofill. But if you want function to be inheritable and you want to keep it private as well, you can use protected. Now let's save it, go here and type override, and we can use start again. It's just going to be protected. Same for the parameters. If you make them private, they won't be available in the circle. They won't be inheritable. But if you make them protected, they will be available, but they won't be visible. This is basically as same as private. So to make it visible, you need to type a serialized field here, so you can see it in the inspector. All right, now we can see shape name. Shape name, it is inherited and it is not public. Oh, sorry, this is the wrong one. Yeah, and it's not exposed to other scripts except the one that inherited from shape. Whew, yeah, all right, very good. I hope that is clear. I hope you got some idea of what is inheritance. And in the next video, we're gonna make a script of the entity that will have some of the same parameters, like flip controller, gizmos, and collision checks. Then we're gonna do inheritance for player from that script, and we're gonna create a skeleton that will do inherit from the same script. You'll see what I mean by that. Let's go to next video. Hello guys, in this video we're going to continue to discuss inheritance. Even though in the last video I gave pretty good example of what is inheritance, I doubt it's enough to explain and understand how inheritance works, because we need more practical example to understand how we can use it, how we can utilize it in our project. And something else I want to say before we begin, we're not going to work on the player controller anymore, because from this point it actually would be harder to manage. It would be more difficult to keep making player controller here rather than if we would have state machine that we're going to develop in the main part of the course. As I said, I just want you to be ready to know some stuff if you never done anything, or even like if you have less experience, very little experience in Unity. But we're not gonna do anything else here. We're just gonna use it as a practical example for inheritance, and then we're gonna wipe out everything and start over and make a finite state machine. That was the plan. That was my idea for this course, because I don't want to leave behind those who doesn't have much experience but still want to make an RPG game. All right, so how we can use it, what we need to do. First, I'm gonna delete this circle and shape. I don't need this anymore, so I'm gonna delete shape. I'm gonna delete circle, and I'm going to create an object that is named, well, let me delete these two as well, switch on the player. I'm gonna create a C# script that I'm gonna call entity, like entity or an object, right? Or it could be named as a like character, something like that. So what we need to do here now, we need to find code that will be useful not only for player but for enemy as well. Like for example, for sure enemy gonna have rigid body, and for sure enemy gonna have animator. So let's go to entity and type here protected animator. I'm gonna name it anim, and in the start we're gonna do anim equals to get component in children of animator. Then we're gonna have a rigid body. I wanna type it above, protected rigid body to the RB. And here we're gonna do, oh wait, let me highlight the mouse, I forgot to do that. All right, yeah, so we're doing RB equals to get component of rigid body. Good. And we need to make this inheritable. I'm gonna do protected virtual void start. I'm gonna do same for update, just in case, protect virtual void update. I'm gonna save it. I have a habit of saving stuff, I don't know why, but it's a good habit. Now, what else we need here? We can delete it from the player now. It's gonna show us some errors, but it doesn't matter, it's okay. We can delete this start, and actually we can just do inheritance here. We're gonna inherit from entity, cool, and do override start, yes. And we're gonna do override of the update as well, but I don't want to delete it so we don't lose this code. So I'm gonna do just protected override void update. And here we need to type now base.update. Good. What else we can inherit? Collision checks, one of the reasons we're doing it. So I'm gonna cut it out from here. I'm gonna go to entity and I'm gonna type, I'm gonna paste it in, and we can just do again protected virtual void, and this is grounded boolean should be inheritable as well. So we need to remove it from here, from collision info, go to entity and type here protected is grounded, protected bool is grounded, and we can type collision checks in the update. Wait, is grounded. Yeah, now let's finish this ground check, and then we're gonna do a little stop so I can explain what we did and why. Okay, we can cut out this as well. Let's cut it out. Go to entity, paste it in here. We just need to make this protected, this one as well, protected. Okay, we did it. Now let's discuss what we did here. You already know this code, right? the ground check, how we doing it. We have a boolean that says if object is grounded, we doing raycast from some position to some direction with some distance on some layer mask. What we're doing here is we're using same parameters, we just write them on the entity script as a protected value. So scripts that are inherit from entity, just like our player, has access to it. So now I can go here and I can find ground check distance, for example, or I can find boolean is grounded here. So because we did that, we still can use this boolean is grounded in the player jump function, for example. Where's jump? Here. Because now, even though we don't have is grounded boolean on player script, right? We don't have it here. We have it on the entity script, which is protected, which is now available to player as well. What we did for start function, we made it protected, which I remind you is same as private, but makes functions or values available to scripts that are inherent from this one. Virtual void start, and player has start function here, which does contain all of this code. So we just basically using it the same way. Regarding collision checks, we can delete it from here, from the player, because we have collision checks in the base.update, which is update of the entity over here. And this collision checks does everything they did before. Very good, very simple, very understandable. I hope you get me. Something else we can do as inheritance, because we're gonna use it for both objects, is a flip. All right, so we have a flip function on the player, right? We have it here. And I imagine if I would create a skeleton enemy, I would need the same script. I would need him to flip from one side to another when he fights or when he walks around. So what do I do here? I take this code, private void flip, cut it out. I'm going to entity. I'm going to paste it maybe somewhere above. No, let's do it below. Paste it in and make it protected virtual void. Now we need facing direction and facing right boolean, so we can cut them out as well. Let's find them, cut them out, go to entity, paste them in and make them protected. So now we have a flip function protected virtual void, and we still have it available on the player, again, because we're doing inheritance from the entity. And something else I want to say here, we not only have a code that we can utilize and use for different objects like player, enemy, can be a flying enemy, anything that uses flip, we can use it now if we inherit from entity. It also kind of clearing the player script, because now we have less amount of code here. It is easier to read now, and still it uses the same functionality. Actually, we should go and check that. I'm gonna save the player, I'm gonna save the entity, I'm gonna go back to player. We even have same values. We could put a header on the player, I guess. Let's do it. Let's find here and type header, move info, save. Okay, so we have collision info, move info, dash attack, all same as before. And now if I go to play mode, it's gonna work exactly the same as before. You see? All things are the same, which is really good. Really, really good. Let's see what else we're gonna need. Okay, I found only one, the gizmos. We need gizmos as well, so I'm gonna cut it out, go to entity, go all the way below, paste it in and make it protected virtual void. And one last change I wanna do is to make a ground check for player and for all of the objects we're gonna have, because at the moment we're doing a ground check from the center point of the character, but sometimes for some reason we need a ground check in front of the character. Like when we have an enemy, we're gonna check if there is any ground in front of him, and if there is no ground, we're gonna flip the character. So what we're going to do here is
go to player, we're going to create a serialized field transform. Sorry, we're going to entity, and over here I'm going to do serialized field, protected, transform, ground check. So we have it like a ground checkpoint. And instead of transform position here, we're going to do ground check position. And on the gizmos as well, the same. Ground check position. And let's do it. Okay. We have it now. It's almost the same. Just instead of the transform of the object itself, of the player, we're going to use transform that we're going to create right now. Going to go to player, create empty, ground check. Now I'm going to drag it to ground check over here. Now we have the ground check that we can use and move. I'm going to set 0 on the X. I'm going to move it below to the feet of the character like this. Yeah, like so. It's okay. Now, yeah, it's okay. I guess this should be fine. Now I can decrease the value to something like 0.5 just to be safe, and it's going to be the same. Cool. Now we're done for this video, and I hope it was not all confusing for you. I hope it's fine. I'm just gonna do a quick review. If it is confusing for you, you can just basically consider it as we took some part of the code and put it on the parent script, so it does not show up here. So we have more space and we have less code here that we need to manage. So it's easier to read, right? Because some code is here, and you know what player needs is only here, and whatever else as a base serves in the entity script. Now let's go to next video and make a skeleton.
Hello guys, you'll have archive attached to this video, and first what you need to do is to open it and copy these two files to graphics folder in the project, just like this. That's what we're gonna do, and we're gonna use inheritance that we created before to create a skeleton. We're not gonna make a full complete skeleton because that would be kind of a waste of time. We already know the base, how to make animations and how to attach them to the code so object can move and can be animated at the same time. In this video we're only gonna use inheritance, and we're gonna try to understand how easy it is to create new object if you have some code written before that you utilize to make new objects or new behavior. Alright, and then later in the course, in the main part, we're gonna create a proper good enemy that behaves and acts as it should be. Alright, so what we're going to do here is to drag a sprite of the skeleton to the scene, just like that. Then we can close the sprite sheet and forget about it. I'm gonna rename these to animator, even though we're not gonna put animator now. Potentially we could do it, right? Then let's click right button and choose create empty parent, which I'm gonna name as enemy skeleton. Now let's move a picture just a bit to the right, so the sprite will be centered more properly. So we kind of like have a center of the object in the center of the sprite. For that, we're gonna select animator and move it to the right slightly. Now we can see it is in the center. This is okay. Now we can add a rigid body to it. Rigid body, we're gonna need a rigid body. And let's add capsule collider. Let's adjust the size. We can make it a bit bigger because that's the enemy. Yeah. Should be easier to hit, so we can make a collider bigger than actual picture is. And now we actually need to create a script. So let's do that. Let's create C# script that I'm gonna name just as enemy skeleton. And let's open this. So first what we want to do is to write inheritance. As you can see at the moment, if I drag my script on the enemy skeleton, nothing gonna be there. It's gonna be empty. Come on, man. So it's nothing here. But if I go here, delete mono behavior, and I'll write entity, then save it, or we can delete start and update, and save it. We can see things change now. Now we have collision info that we can use same as we used for player, right? And we can add some behavior that we want to. For example, we want character to move left and right with a certain move speed and so on. But first, let's do override. Let's do override start, and let's do override update. So it has collision check in it, because we have collision check in the update over here. And now let's set up a little movement for the skeleton. Need a move speed, and I don't want to have move speed inherited because it will make kind of mess in the inspector. Like move speed line will be together with the collision info, and I prefer to have a header for certain type of information like we have on the player. That's why exactly in this case, I'm not going to move speed to entity. I'm going to keep it on the player, and I'm going to create another one on the enemy skeleton. Private float, move speed. And I'm going to give it a header of move info. Now in the update, we can move skeleton. We can do rb.velocity equals to new vector 2, move speed multiplied by facing direction. And for the y, we're not going to change it. Now, skeleton going to move only to the right side because he's facing right and we don't have any flip functionality yet. Now, let's create an empty object for ground check. Drag it to ground check. Let's make a ground check distance, maybe 0.1, and we can move it below, ground check, we can move below to the feet, like this. But it's ground. We're not going to use ground check at this moment, we're just going to set it up. Okay. And move speed, let's make 1. Just slow movement. I'm going to move it to the left and see this. Oh no. So we need to fix something here. If you remember, we did this before. We did this fix. So I offer you as a small challenge, make him not to fall on the side. I'll count a bit. You can pause the video, try it, and then resume the video, okay? 3, 2, 1, okay. So what we need to do is go to rigid body and choose freeze rotation Z. And while we are here, we can change collision detection to continuous and rigid body to interpolate. And gravity scale can actually be something like 4, something heavy. In case he's falling off the ledge, he's gonna fall fast. Now let's see this. He's walking slowly to the right. Good, and as you can see, it was very easy to set up because we already have access to rigid body and we have update, everything is set it up. We just need to type some lines of code and it works. That is one of the benefits of using inheritance. You don't need to do your work twice. You don't have to declare a rigid body here with RB. You don't need to access component of rigid body. It all would be a waste of time to do it twice. It's better to do it this way. Now, we need to make character flip. First, what I want to do is to make him flip if there is no ground in front of him, if there is nothing. For that, I'm going to place him on the top over here. And I'm going to move this ground check in front of him. And actually, in this case, I can make it a bit longer. But it doesn't matter much how long it is. It all depends on the structure of the level. If we face situation where it is matters how long it is, we're gonna do something about it. But for now, this is okay. Now it is in front of the character, so he is checking ground in front of him, right? Now we're gonna go to update and type if not is grounded, means there is no ground detected, then we're gonna do flip. And again, we have this is grounded and flip on the entity. Probably you already understood that by now, and I'm just a bit over explaining things, but I just want to be safe on this part. We have is grounded and flip function made in entity, and because we're doing inheritance from entity, we have access to these things. Now look at this. He's walking, and boom, flip. Good job. Now, what if he's facing a couple of walls in front of him and behind him? right? We need to make a wall check. And it also would be nice to have a wall check for player in case we want to have some kind of a wall slide or wall jump ability. So let's go to the entity over here, create new transform, serialized field, protected transform, wall check. Then we need distance, serialized field, protected float, wall check distance. And we need a boolean that says wall detected. Protected bool is wall detected. We could just type wall detected, but it's better to begin everything with the is. So we have kind of like all of the collisions begins with the is. So we know is ground, is wall, is something, is detected, and it's easier for us to find whenever we write some code later on, like is, then this. If is, and we have is wall detected, is grounded, and it's kind of good practice to keep it with a similar name so it's easier for us to find. Now we have ground check, we have wall check, we have layer mask. I want to move it below so it kind of organized next to each other. And we can put a space here. It will make a space in the inspector, which also makes it look better. Now we need to make exact the wall check. First, let's draw a line so we can see it. I'm going to do gizmas, draw a line from wall check position to new vector 3. And remember, we're doing check in horizontal, so we need to do wall check position.x plus wall check distance, and we need wall check position.y because it's the same y. So we have kind of vector 2, and we draw a line from the x position plus distance, and it will be on the y position, so just a straight line to the right. Yeah. Let's see this line. Let's create empty wall check. We're gonna drag it to wall check over here. We're gonna make wall check distance. Maybe just 0.7 is okay. I think it's okay. Good. Now we see we have a wall check. There is one issue though. When he flips, the wall check still gonna go to the right side. Look at this. He's flipping. Wait, I need to remove this. So he's flipping, but wall check goes to the right still, because we did not change the value. It still goes plus wall check distance, which is 0.7. So to fix this, we need to multiply value by facing direction. Let's go to entity and do wall check distance multiplied by facing direction. Now let's see this, and then we're gonna continue. So now if I'll remove this so he can flip. Now he flips, and we have wall check to the left, as you can see. Cool, now we can use it. Let's go back, and remember this was just drawing a line. It does not do actually anything. But if we go to collision check and make is wall detected equals to physics 2D raycast from wall check position vector 2.right, and then it's going to be wall check distance multiplied by facing direction. And what is ground? Let's save it, and then let's go to enemy skeleton, and here we're going to do or is wall detected. Okay, it's gonna flip and flip again. So now basically we have a patrolling enemy that goes left and right and checks if anything is there or anything is there. Yeah, what's happening with our player? What is it? What's up with you, girl? I guess it's because of the wall check. So she doesn't have a wall check, and it's kind of buggy behavior for her. So we need to create an empty object, or we will create an empty object for wall check transform, but I want to show you just a little trick. We can go to entity and type here if wall check equals to null, means it's empty, then wall check equals to transform. And then if you don't assign the value, it's going to be filled with the transform of the object itself. Look at this. Player. So we kinda saved ourselves from our stupidity. Yeah, good. Now, what else we want to do here? We want to detect the player and attack him if we see him. We need this kind of behavior on the enemy skeleton. That's going to be super simple to do as well. We cannot make a player detection on the entity because, for example, player does not use the player detection. He does not detect himself. So it's kind of pointless to write it here. Good for us, we can override the function and then just add the functionality. We're gonna go to enemy skeleton over here and type override collision checks, and then after the base we're gonna make another one. And this time I don't want to use Boolean, I want to use raycast, which allows you to have a bit more flexibility when you detecting the object. All right, let's do this. Let's do header for, you know, like I don't know, the player detection. Let's make it like the player detection. Yeah, inside we need serialized field, private float player, sorry, check distance. Then we need a layer mask. Layer mask, what is player? And I'm gonna create not a Boolean this time, but raycast itself. It's gonna be private raycast hit2d player is player detected, or detection is better, player detection. Okay, now I'm gonna go to collision checks over here and type is player detection. Sounds kind of weird. Is player detected should be, I guess, or player detection. Let's rename this, and I'm gonna show you a useful hotkey which allows you to rename things all across the script. We're gonna press Ctrl and R. Yeah, and we're gonna do is player detected, a bit better. Now equals to physics 2D raycast from, we can use transform position this time, or we could utilize the wall check, but we're gonna use transform position, doesn't matter much. Now vector2.right wall player check distance multiplied by facing direction, and what is player as a layer mask. We need a Boolean that kind of says if he is attacking or if he is aggressive. So I'm gonna do is attacking, bool is attacking. By the way, when you don't declare private or public, it means value is private by default. Now I'm gonna go above and type this. If is player detected, we're gonna check distance to detected object. If is player detected dot distance is bigger than, I don't know, 2 or even bigger than 1, then we're gonna just walk. I'm gonna duplicate this movement. And sorry, that was kind of weird, right? I just moved the line up. We're gonna walk and we're gonna debug log I see the player. And to make it a bit different, we can just multiply move speed by some value, like he's walking faster when he sees the player, when he's aggressive. So I'm gonna do multiply by 0.1f, so it's gonna be slightly faster. If distance is smaller, else we're gonna do debug log attack, and we're gonna do plus is player detected. So he's gonna debug the name of the object. And we're gonna stop his movement. I'm just gonna do that by setting is attacking to true, and we here gonna set it to is attacking false. It's kind of, you know, like a bit of crappy code, but we're doing this so we can stop movement of the enemy if he is attacking. Let's just take this and extract method movement, and already you can see how we can use inheritance for the movement, but we're not going to do it. It's just a quick example that we're not going to actually use. So if not is attacking, he can move like that. Yeah, cool. Now let's see this. Let's go back. Oh, we actually need the gizmos so we can see the line. So let's override gizmos as well. Override gizmos. We're gonna change color of the gizmos so we can see it in different color. Gizmos.color equals to color dot, let's make something noticeable like blue. And then we're gonna do gizmos dot draw line from transform position to new vector 3
and it's going to be transform position.x plus player check distance or multiplied by facing direction, and for the y are transform position.y. Okay, it's kind of just an example so we can see how does it work. We're not going to use this code, and there is certainly a way to make this code a little bit better, but again, I'm telling you, this is just example so we understand the things like raycast hit, that we can use distance of the to the object or something else. Okay, let's see this in the action, and then we can discuss it a little bit. I'm gonna go to enemy skeleton, say what is player, or we actually need to create a layer. Let's do this. Let's go to player, add layer, player, then choose layer over here, not this object only, this is fine. And for enemy skeleton, we're gonna go here, what is player, player, and player check distance, let's find it. So maybe, I don't know, like 4 is okay. I'm gonna move up this platform. Let's go. He's moving, he's flipping, he's going to the direction of the player. I'm gonna open console. We can see I see the player, and now we can notice he's moving a bit faster. And when he reaches certain distance, he is stopping and he is attacking. Unity Engine raycast hit 2D. Okay, we can change this. Let's go and try that. It's gonna be like .collider.gameObject.name. Yeah. And I'm gonna give him a bit more move speed. Maybe 3.5. He is moving, and then he stops. Attack player. And he's kind of attacking. And as you can guess, instead of debug line, we could do some functionality that is responsible for attacking the player, like play an animation or some other stuff. But we're gonna do it in the main part of the project with the state machine system. That's it for this part. Let's just review the code a bit, trying to understand it again, and then we can move to the next video. I'm gonna stop this. So what we did here, we created a new script which inherits from entity, and this allows us to use such thing as a detection of ground or wall or flip function. We could possibly inherit a movement function and make it usable for different objects, but we're not gonna do it now. We did override of the collision check, so we have a base functionality of these two, plus a new functionality that only skeleton has, but player does not have it. If you do override of collision checks here, it's not gonna be there, yeah? Then we did again override gizmos and wrote a couple of new lines of code so we can see detection of the player. And this time, instead of the boolean, just to say true or false, we used a raycast hit2d variable, which can be used for different purposes. Like for example, we used distance to add some functionality, or like we used access to the collider, to the game object, to the name. And in general, when you use raycast like this, you can just do is player detected and have a bunch of information like distance, collider, center, so many things you can do here. Like you can do collider.getComponent and get access to the script, for example, and then call some function damage, which does not exist, but possibly we could do it. So many different functionality you can do with the raycast hit2d. So that's it for now. I hope it gave you some understanding on the inheritance, how we can use it, how we can utilize same code for different objects, which is really cool, which is really useful. There are gonna be only one video in which I'm gonna prepare you and prepare the project and give you some couple of advice to go, and then we're gonna go to main part, creating a fully functional RPG game that is scalable, where you can add like bunch of skills, even 100 if you want, and use it as you want. See you there.
Hello guys, this is the end of the section 0 we had here. kind of a, we can call it, I guess, a crash course on Unity, on things you need to know before we begin, I would say. Yeah, and well, yeah, actually it's a pretty good explanation. A couple of hours of tutorials as the things you need to know before we begin is something that explains it very good on what we're going to do. But don't get scared, don't get discouraged. Remember, we're about to create an RPG game, which is kind of a big deal. You know, like when you start the game development, you create a platformer or endless runner or maybe some top-down shooter that is really simple to create. Even here, what we have here in our game, it's basically we have a platformer, right? We have jumps and walk left and right and so on. But creating an RPG game is something bigger. It's not only about a character being flexible and scalable with multiple skills. There are also items, stats, maybe XP bar. We're not going to have XP bar, we're going to have a souls like in Dark Souls, but still, you know, lots of things, lots of mechanics and systems. And I will walk you through it. Don't worry, it's not going to be that difficult as you might think or as I might draw it. It's going to be pretty simple to understand. I just need some time. And I want to say in the next section, I'm going to, it's kind of like we have a little secret between us. I'm going to act like nothing happened, like there was no section 0. All right, I'm not gonna refer to anything we created in this series of the videos. I'm not gonna talk about anything in here. I'm just gonna start over like, hello guys, this is the first lecture. Welcome to the course. Let's begin with creating a state machine, something like that. Yeah, I'm still gonna explain a lot and we're not gonna go over the same details. Just, I don't know, I really, you know, I got admitted a lot of courses when I just began. Lots of them. And first couple of courses was okay, was good to know like the basics, how the method is called, what is a float value, or how you can make character walk. But then after like 1 or 2 courses, each and every course was so irritating, annoying, and slow in pace because every dude decided that I need to know what is a float again. It's just an example. I mean, not float exactly, but they given basic information in such a slow pace, I was just getting tired of each new course. So I decided I won't be like that. I will make something different. I'll make an extra section for those who wants to learn that information, and then I'll make a main part for those who doesn't want to learn that basic information, and still it's gonna be like no one left behind and no one is irritated by slow pace of the beginning of the course. Yeah, I'm gonna create a new project in the new section, so we're not gonna have any of these. I hope that won't make you upset that we are deleting everything. If you want to keep some stuff, you can keep animations folder, because we're gonna create animations anyway. But again, it's just like what, couple of minutes to make them, not so important, so you can just follow along the stuff I'm telling you in new videos. Thank you for beating the section 0. Thank you for this, and let's go make an RPG game. I'll see you there. Oh, and I hope you are not upset we did not finish the skeleton. Finishing up skeleton with the attack animation and damage system was not the point of these last 2 videos. The point was to learn more about inheritance. I hope you understand that. Yeah. Let's go, see you there. Hello guys, in this video we're going to discuss state machine. We're not going to do any coding yet. Goal of this video is to understand the concept, the idea of a state machine. How does it work and what can be done with it? I will begin my explanation with a state machine of a traffic light. I'm sure you've seen it many times and you understand it pretty well. So a traffic light state machine is responsible for switching between states on a certain condition. Those states are, as you can see, those states are green light, yellow light, and a red light. They can have different conditions for switching between them, like a button on a control panel or a timer, for example. Let's see another example of a state machine which is a bit different but still very simple. This is a Quest state machine from any RPG game you played before. Again, state machine is responsible for switching between states on a certain condition. In this example, Quest cannot be accepted unless it's available. So this is the condition. Quest should be available before you accept it. And same goes for completed state. It cannot be completed unless Quest is accepted. So you cannot go from available to completed directly. exactly what they possibly could do as a state. Available state could show, a little exclamation mark above the head of the character. Accepted state could show you list of the tasks on the right side of your screen, for example. And completed state could have a behavior which would give you items in the end of your quest. And failed state could just give you a message like quest failed or something like that. Let's see a different state machine. This is a state machine of a character. As you can see now, it has only 3 states. It is idle, jump, and attack. Obvious condition here is that you cannot do jump while you're attacking. You can see it represented by arrows over here. Yeah, and same goes here. You cannot attack while you jumping, again, because it has certain condition. If you want to attack, you need to be on the ground standing. Another condition could be the input. For example, idle states listen to the input of the player when he's standing, and if you press attack button on your keyboard or your gamepad, it will go to attack state and it will play certain animation and it will do some damage, and then it will go back to idle state. Because states are independent from each other, it doesn't matter if you press a jump input at the moment of the attack. State cannot be interrupted unless it has certain condition. This gives us incredible flexibility and control of the code. To sum up, state machine allows you to make each state independent from another. Changes to one state will not impact another state, which again gives us incredible flexibility and control of the code. Now let's take a look at the same state machine, but with a more practical example. This is basically the same what you've just seen before, with a couple of more states, which I'm gonna talk about later. So this is the ground state. Ground state means player stands on the ground. Doesn't matter what he does. And it has kind of like substates inside. It can be idle or move. What is a condition for going from idle to move? Right, it's the input on the X, which is like arrow keys, for example. If you do not press any X input, then we're going back to idle. And this is how it works inside of the ground state. Well, you just walk in and stand in here and there. If you click attack input, you go to attack state. So this is the another state. Same as before, it will play some animation of the attack, it will do some damage, and maybe knock back the enemy, something like that. And then when attack is over, that would be condition for transferring back to grounded state, in which you can again move or stand. If for some reason you get off the ground, here it is, we have condition not is grounded and is grounded. So if for some reason you get off the ground, maybe by pressing a jump button or going off the ledge, you go into the air state. And in the air state, as you can see, you cannot attack. You don't have transition to attack state. You don't have a transition to move state. You can be in the air. And from there, you can go only to a couple of states. First, if you detect in the wall, you would go to wall slide. If you detect in the ground, like you landed on the ground from falling, you're going back to grounded state. I know it might be a bit confusing, but stay with me. Focus. It's super simple. This is just an example. Our state machine gonna be much bigger, much more scaled, and we're gonna do it on practice, so there is no doubt you will see how does it work. You will understand everything completely. So back to it again. If we transfer to wall slide, from this state we have only 2 ways to go. We have only 2 conditions to switch to another state. If wall not detected, we're going back to air state. If we do jump input while we are wall sliding, we go to a wall jump, which will go back to air state once wall jump is over. And if we touch the ground while we're doing wall sliding, it means we are back on the ground, so we can go back to grounded state. So this is another example of the state machine. Yeah, so it's a bit more complex, but still super simple and explains it pretty well. So to sum up all what we had here, I have to say that state machine needed for switching between states on a certain condition, such as what state can be next, maybe input, maybe like damage, whatever it can be in the video game. And states itself, it's some kind of condition of the object. On the example of the character, it's an idle, movement, attack, whatever it is. Final thought here, states are independent from each other, which gives you incredible flexibility. This is it.
This is the concept, how it's gonna work. Again, this is just a simple example. We're gonna have a bigger state machine, but we're gonna do it on practice, step by step. We're gonna learn how does it work, how to transfer, all of that stuff. It will be super easy. Let's go to next video, set up the project and set up the state machine so it's ready to work.